Alrighty. Hey, hello. Welcome everyone to Azure Integration Services Day. So let's get us started. I know we've got Kent and Wagner here with me as our co-hosts as always, and we've got a couple of exciting presentations for you guys today. So for our agenda, we've got all these lovely presentations. We've got everything about Logic Apps for you, everything that you want to look at. We will have this agenda up on the actual blog post as well if you want to take a look to catch it later. But for now, let's just kind of keep going. We've got a little bit of a tight schedule here, of course. But in our meeting today, we will ask you guys for all of our presentations, since these are a lot of our lovely people here kind of taking their time to have this lovely integration day with us, just to be aware of others, be welcoming and respectful, be understanding of differences, be friendly and patient, be open to all questions and viewpoints, and lastly, make sure we are always kind to others. So let's make sure that we have a really great day today. And we're very excited to share all of our lovely new presentations with you guys. One quick announcement before we get started with our first presentation is we have a brand new branch of Aviators that's coming out. So we are very excited to announce that we have Aviators Germany now. So as you can see on this, we've got a brand new branch here out in Germany. So for anyone that wants to subscribe to that newsletter, go ahead and visit that link down there. That'll be https://ak.ms and then /Aviators Germany. So this is really exciting. So for all of our folks out in Germany, definitely make sure to check this out because this will give you a chance to be more in depth with the aviators community in a way that can be brought to you guys by Quibic. And now I'll pass it off to our first presentation.
And one other thing, just around community, if there's other people that are interested in hosting sort of their own chapter of aviators, feel free to reach out. We're happy to help as much as we can. And help grow the movement of aviators.
Totally.
All right, so I think first presentation is around Azure Integration Environment and Business Process Tracking. And so we'll get Divya added to the show here. And I'll bring up my screen. Oh, of course it did that. Let's just flip this around. Okay, can we just get an acknowledgement that you can see the screen properly?
Oh, yes.
All right, Divya, feel free to take it away.
All right, thank you, Kent. So we are very excited to announce integration environment, integration application and business process tracking that Kent will cover in detail. Little bit history on this, like we've heard from customers for a very long time that they love the flexibility that Azure provides in when it comes to integration, where they can choose the services that they want, and then they can choose it at the pace that they want to, and pay only for what they are consuming. So they love that. But the downside is that compared to the classical integration products that our customers are coming from, they miss that product feeling when using Azure Integration Services. And in some cases, when it comes to management and monitoring experiences, the experience was very siloed across the services. So that's the problem that we are trying to solve. And our vision basically here is to provide you this single pane management monitoring experience that spans across the entire AIS portfolio. And towards that vision, this is our first step where we are introducing integration environment, which provides you this landing zone for your AIS, for Azure Integration Services, where you can build management experiences, where you can bring these things together and get a very unified experience, a cohesive experience across all these services. Integration environment comes with a lot of flexibility in how you want to model it. So it's up to your business needs on how you want to have integration environment. For example, you can have one based on your development environment like dev test prod, or you can map this this entity to your business teams or your business organizations within your company. within integration environment, now then we are adding another concept, which is integration application, which basically allows you to group your pre-deployed AIS components into a unit and use that unit as your management entity. So the whole idea here is that again, like when you have the landing zone, how do you then how do you then bring your business context of the application into this model? So with this, you should be able to group these entities together. For example, you could have a payroll application or an order processing or a shipment notification application. So the whole idea is for you to be able to bring your business context into integration environment through the applications. And for in the first release, we are supporting Logic Apps, service bus entities like queues and topics, and API management APIs, which you can group together and create this unit. And with that, with integration environment and application, the first problem that we have tackled, we decided to solve is business process tracking. And I'll pass on to Ken to cover that in more detail.
All right, thanks, Divya. So let's talk a little bit about business process tracking. So for folks that might come from a BizTalk background, there's a capability called BAM, Business Activity Monitoring. And so what we're trying to do here is we're going to try to solve the same type of problem. We're calling it a different name. It is a completely different implementation based on different underlying technology. But in terms of trying to solve those core business problems, this is basically our successor to BAM. Now, we do envision a fusion dev approach to building out business process tracking. And what that means is that we do want to involve the business subject matter expert to get involved in defining the business process. And naturally, these are going to be the same people that are consuming the outputs of business process tracking itself. And we'll get into this in a live demo, but what you see on screen is our business process designer, where a business subject matter expert, or maybe it's a business analyst or an integration architect, would go ahead and define the conceptual business process by adding stages. Now, for each stage, we want to be able to go ahead and identify the data properties that we might be interested in. So what we've got here is a power outage scenario. There's various stages to that power outage, like creating a ticket, creating a work order, dispatching the work order, having the technician on site. And for each of these stages, we want to go ahead and identify data properties that are meaningful to the business and have those exposed. And so this is where we envision a business analyst or business subject matter expert go ahead and defining these various stages and their related properties. But now we run into the situation where we've got an implementation. We have Logic Apps in place. We now need to be able to go ahead and identify where we can go ahead and collect this data. So for the stage that we're currently on, which is the ticket created stage, we know that we can go ahead and find this information inside of this CPL work order management logic app, and then within this customer service ticket created workflow. And so this would allow us to then identify where in the technical solution we can retrieve this information. Now we've taken it one step further by adding this link. And what this link is going to do is it's going to allow us to load a read-only version of the Logic app, the workflow itself. And we can use this information to go ahead and identify where in the workflow we will go ahead and collect this information. And we do support the token picker. So if you've built a Logic app, you can use this feature. And then what we'll also ask you to do is go ahead and identify at what point of the workflow can we say that this stage is complete. And it's at this stage that we'll go ahead and we'll collect this information and we'll publish it to the backend data store. Now, in this case, our backend data store is Azure Data Explorer. When you go ahead and create a new application, we're going to ask you to bring your ADX instance. So basically select it from a series of drop-downs, and then we'll wire that up inside your Logic app and publish data to it. So you'd go ahead and do this for all of the various stages and subsequently deploy the business process. Underneath the hood, we're going to create tracking profiles for any of the Logic apps that are participating in the business process itself. And when the Logic apps run, we're going to go ahead and emit that data pretty quickly. It's almost instantaneous, and we're pretty pumped about sort of the current performance. And so we're definitely interested in feedback on that. Now, once the transactions start to be collected, we do provide a transactions view that's going to go ahead and list all of the various transactions that have been, involved in this integrated solution. And what's a key concept here is a business identifier. As you're creating these various stages and these data properties, we're going to ask you to also map a business identifier. So this is generally something that uniquely identifies the transaction. So that could be like a case number in this case, a ticket number, or an order number. And that's how we're going to go ahead and correlate all of these different events. Now, the other thing that we do here is we will overlay that conceptual business process that was defined earlier with your actual transactional data here. And so that's where you can see this image, this visual, where we can see all of the various durations for which those stages took place. So certainly if you've got longer business processes, maybe they involve approvals, and you're trying to understand why is it taking so long for this business process to take place, we're going to actually give you that insight and allow you to understand where those bottlenecks exist. Now, the other interesting thing is that because we've chosen ADX, not only is it a reliable and durable data store for us, but it also allows for a lot of extensibility. So this is our initial experience. Certainly, we want to give you the opportunity to extend this and customize it. And through the use of either Azure Monitor workbooks or even Power BI, you can go ahead and consume this information because it is coming from your ADX instance. So that was a very deliberate design decision on our part. So just in terms of scope, before we get into the demo itself, our goals, the goals are really around involving the business user, being able to extract key business data and make it available to stakeholders that are interested in this information. What we're not trying to build here is the Uber operational support tool. So this is not the tool to go ahead and to do message body tracking, right? We've already solved that problem. Could there be opportunities to do some sort of deep link integration in the future? Perhaps, but we are very much focused on the business persona in this case. So let's get out of slides and let's jump right into a live demo. So let's just head over to the Azure portal. And as Divya mentioned earlier, we do have environments, integration environments. And so here's an example of that integration environment. The environment itself is going to include applications that you go ahead and you model inside of the experience itself. Let me just do a quick refresh here. Okay, I think my token had expired there. So we've got, in this case, 3 different applications that have been configured. We can see the various business processes that do exist. If you were at the Integrate event this past June, you also saw application monitoring. That is something that is still very much part of our roadmap. It was just one of those things where we did have to prioritize some features in order to hit this Ignite timeframe. So do look for more opportunities in that space. So I've got my applications. I've got one here called a customer service power outage. And as part of this particular application, I'm going to have multiple resources that play a role inside of here. So I've got multiple Logic apps. These Logic apps include, one or more workflows. We also have queues and APIs that are in the mix as well. And certainly when we get into application monitoring, that experience becomes even far more valuable. now what we can jump to is our business processes. And what we've got, I've got, kind of 3 different versions that are being worked on here. We can see I've got one that's been deployed and it's available for use. And then I also have the ability to go ahead and view those transactions. But let's take a look at a business process that's in flight. And so here I've gone ahead and I've created the various stages. I've gone ahead and added properties. I can go ahead and determine the data type for those properties. And I go ahead and continue to model that throughout the business process. Now, one thing you might be asking is, okay, this looks like very sequential, but my business process has conditions, or my business process has concurrency. How do you sort of deal with that? Well, we do offer parallelism. So what we can do is go ahead and add a parallel stage and go ahead and just add that. And then we can further model this out. So we certainly have the ability to support more complicated use cases as well. So that's something just to be aware of. Now, we talked about, the business subject matter expert, initially performing these different actions. Now, the question is, okay, well, how do I go ahead and sort of include the developer? Because the developer is the one that's built the solution. They're the ones that are going to know where are the logic apps and the workflows where I can go ahead and collect this information. And so that's where you can go ahead and just click on the show data source. Here you can go ahead and select from a logic app that's been configured inside of your application. So here I've got 2 logic apps and I've got a particular workflow that I want to go ahead and select. Once I've got that in place, I can then go ahead and click on this link. And this is going to bring in a read-only version of the designer. And this will then allow me to choose at what point in the process do I want to emit the data, and then where am I going to go ahead and get that data from. So this is the token experience that you've seen and used previously, and you can go ahead and use that. We also do support functions as well. So if you need to do any sort of string manipulation or concatenation or formatting, certainly you would have the ability to go ahead and do that here as well. Now, we talked about the business ID, and so this is something that you do need to provide at each stage. This is going to allow us to correlate that information. And same idea is I need to be able to go ahead and find that from within the Logic app. And when I go ahead and emit that data, that's where this information can all line up from that perspective. So just to sort of ground ourselves in a real world demo, we've got a scenario here inspired. Oh, why does it do this? By one of our customers, and they're a utility company, and in this case, we're using the Microsoft Contoso version of it, City Power and Light. And this utility, this power utility, obviously offers customer service to their customers. And here we've got Lydia, who is a customer of City Power and Light. And so she's encountered a power outage at her home and would like to report it to City Light and Power. Now, as her internet's down, she'd like to report this issue using her mobile device, and preferably through a conversational AI chatbot, or what we're now calling Copilots. And so once she goes ahead and creates the service ticket, she'd like to be able to check on the status of her ticket through the chatbot as well. And naturally, once the outage is complete, she would like to be able to receive communication about that. So this is what the underlying technical solution looks like. You can see we've got various systems in play here. We've got a CRM that's hosting the chatbot. We have a work order management system that is being used to dispatch orders and collect updates on those orders. We also have processes to deal with communicating back with customers. And it is a very distributed application made up of multiple logic apps, service bus entities, APIs as well. And so that's where we can go ahead and define a conceptual business process that looks kind of like this. Inside of the CRM, we're going to have a ticket creation process. Then we essentially have a handoff over to a work order management system where we're going to run it through the various stages as part of that business process. And across each of these different stages, we're going to go ahead and collect different information, from that business process at those stages. And so this is where, I think this solution really shines in the sense of when you have multiple systems in place, you're orchestrating a business process across those systems. How do you go ahead and collect key business data across those? And then how do you go ahead and expose that to your business users so that they can actually consume that and ideally, use that information to better manage their business? And so that's really the core of what we're trying to solve here. So with that explanation out of the way, let's head back to the Azure portal. And here we do have that deployed business process. We can go ahead and just click on the View Transactions button here, and we'll just let these transactions load. And here we've got some simple filters around being to filter by like the ticket number, being able to filter based upon a prior range. We have those capabilities. And like I said, we will be enhancing this as we move forward as well. Now, let's go ahead, let's create some data. So here we're at case 1129. We'll head over to our chatbot. And here I'm using Power Virtual Agents, or what's now known as Microsoft Copilot Studio. And I've got that chat experience that's exposed. And this chatbot is going to talk to the CRM and provide the customer service experience. So here I'm acting as Lydia, and I want to log a ticket. So I can say my power is out. And so it's just asking me to confirm, yes, I do have a power outage. And then it just needs some additional information here for me to validate or look up my record. So I'm just going to provide my email address. I'm being asked to validate my site ID. So I'll go ahead and do that. Now I'm being asked to provide some additional details that may have contributed to the power outage. So in this case, I'm going to say, big storm, tree fell, just to keep it brief. Okay, so now a ticket is being created. And here we've got case 1130. Now, earlier or I guess it just mentions it here. If we want to be able to go ahead and come back and see the status of our ticket, we should be able to issue a statement of ticket lookup. And then we're going to be asked for a ticket number. And here we can see that the status is in a created state. So if we actually head over to the Azure portal, we now see that we've got a case has been created. We can click on it, and we can see that the first two steps are complete. We've got ticket created, and we've got work order created. And if we go ahead and click into these various stages, we can see the data that was captured at that particular part of the business process. So let's go ahead, let's proceed. And we now are playing the role of a dispatcher who's basically received a ticket and needs to assign a technician to go ahead and to solve that. So here, playing the role of our power line technician is going to be the one and only Harold Campos. And, we're going to change this to be in a dispatch state. So now we can see that it's the work order status is dispatched. If we come back here and let's head back to the Azure portal and we hit refreshed, we now see that the work order has been dispatched and it's been dispatched to Harold. Oh, I can leave that open. All right, so let's continue on here with the process. So Harold now has picked up the ticket. He's traveled to the site. He's now on site. He's asked to look around for any sort of safety hazards and has noticed a large pet, a large dog, backyard. But Harold, being astute, has brought treats, so the dog is not an issue. So that's good. So he's now on site, and we've now advanced through that part of the business process. The job's now done, so he can go ahead and just indicate that this is complete. And at this point, he can just indicate that he replaced a power pole and can give the material ID for that particular power pole. Go ahead and can click the confirm button. And if we head back over to our chatbot and we do a ticket lookup, and we provide our case, we'll see that it's now complete and your power is restored. If we head back over to our business process here, we will also see that the work order has been complete and the customer communication has also been sent out. So that concludes the demo. I think, I don't know if there's any questions, but I'll go over some frequently asked questions that we do receive about this feature. So one question that we often get is, I see Logic Apps in the mix here. What other sources do you currently support? So as of right now, as of this current public preview, this is very Logic App centric. This is based upon our workflows. We are looking to provide extensibility though, and make this available to other services as well. And so that's where we need your feedback and your scenarios. So do reach out, do even in chat if you want to sort of provide some feedback around what are the services that you'd be interested in having this. That's what we'd love to hear. And that could be Azure Functions, or maybe it's an SDK, that could be a RESTful API. We've heard some people ask about API management. We've also heard some people talk about service bus queues and topics. So, feel free to stack rank them if that makes sense, but we're definitely interested in sort of what are the options there. Another question that we often get is, how do I deploy this through CI/CD? And so for now, once again, in the preview, like we just launched this a week and a half ago, that we are focused, where for now it's in portal, but we are definitely have plans for exposing this through CI/CD. So that is something just to be aware of. And then another FAQ is, what about looping? And that's another area that is on our radar as well, to support the more granular ability to track data inside of a loop itself. I hear someone's come off mute. Is there any questions or?
Yes, we have a number of questions here. The first one, I think, is from Taha and from Richard. Is a question about how is that different from resource group? So for the SAFs environment, right? So Taha asked that, and Richard asks like, how can we can group those under resource groups as well? So how that feature is extra? What is the difference between that?
Yeah, it's a great question. And so the resource groups is a very sort of common way of organizing your resources. And largely, I think it does make sense. I think the challenge is, though, as you have like n number of, say, resource groups or n number of like solutions, how do you start to look across those? Like, do you go one by one? Do you click into each Logic App one by one? And so when we think about integration environment, it's more of creating a hierarchy. And as Divya mentioned, you've got like a few options there, like can be dev, test, prod, UAT, staging, or it could be this is finance, this is marketing, this is operations. And so based on your operational model, there might be sort of different sort of permissions that you provide as well. And so if you're responsible for, say, production support, or you're responsible for marketing support, how do you want to efficiently go ahead and sort of view those resources, manage those resources? And I feel like once we offer the application monitoring, then that's where the value really starts to shine. So hopefully that's answered that question.
And also across not just multiple Logic Apps applications. So the click factor minimizes as well.
Yeah, for sure. Like it's more than Logic Apps too, right? It could be like Logic Apps to API to functions to service bus, and now you're like clicking in each of those resources. Like that's not the optimum experience we're after. So.
which I think brings to that question from Rich again, like the monitor we can do with Azure Monitor and Azure Workbox, what we can have extra here.
Yeah, great question. And so when we talk about monitor, what we're interested in doing is we're not trying to reinvent that wheel. This, I think, is the power of Azure, where we actually can go ahead and build experiences in conjunction with other teams. And so what we showed at Integrate was how we can take Azure Monitor alerts and actually then bring them into context. And I think that's one of the challenges is that, Azure Monitor is a wide sort of, scale, big scale, like monitoring solution, but it doesn't understand the business context. And that's what we can actually provide by saying, like, these are the resources that are part of the marketing process or this power outage resource. Let's now build a monitoring view on top of that and only bring that information into view, because Azure Monitor can basically monitor your entire enterprise.
Thanks, man. Next question, I have two more, and then I think that that's it. I'll have to see if there is any other new one here. One is from M. Velling. Will consumption logic apps be supported at some point? And that is reflected by Slava Chernenko that's also asking, it will work for consumption logic apps or it's just for standard logic apps?
So at this point, this is a logic app standard feature. Never say never, but like we are very much prioritizing logic app standard. And just to sort of give you a little bit of insights into like why standard, like the architecture really lends itself for this. So when you actually go ahead and click the deploy button and you deploy a business process and we create those tracking profiles, we put them into your logic apps. We are actually using your compute. Your compute is actually, we're attaching to those various jobs that are taking place and then emitting the data over to ADX. That model in consumption doesn't work. It doesn't quite work that way. It's a multi-tenant service. And so when this is actually happening, it's happening inside of your logic apps. And the other thing I will say is, at least in preview, like we're not charging anything extra for this, right? You're bringing your own ADX, you're bringing your own compute in the form of your app service plan or your workflow service plan. And as a result, like you're emitting those events. And so, it's something we'll continue to listen to feedback on, but at this point, we are very much focused on standard.
Cool. And one last question from Richard here is what happens, how it will handle the logic apps if it's erroring or failed? And I think that question was on the context of business process tracking.
Yeah, no, great question. And this is another area that we are working on for our GA. And so we completely understand sort of the scenario, right? Where you've got, transactions that are in progress. How do you identify when something is like complete and successful, something that is in progress, or something that is complete but failed, and being able to identify what I would call like milestones. And so we're calling this like milestones management. And, that is something that is also on our radar and something I would expect to see there for a GA.
All right. Just going through the other questions here. So we have any plans to integrate with durable functions?
So that's where we need this feedback. I think, it's one of those things where if we use like an SDK approach, or if we used a RESTful API approach, those would be sort of more of a broader solution to sort of a variety of different technologies. But we definitely are working on like how do we externalize this and make other services, resources being able to participate in this model. So yeah, that's the second time I've heard durable functions in the last week or so. But keep the feedback coming, because we definitely want to make sure we're hitting the largest number of use cases we can.
And the last question, because we're running out of time, Joju Jacobs is asking, will the multiple runs for the same business key be displayed for them? How we dealing
Yeah.
with?
Yeah, no, we have some internal tracking identifiers as well, and so those don't collide. So like we also get the resubmit question, and so I think there's probably another sort of indicator or an enhancement we can do around that, but we do manage that today. So if I resubmitted transactions for that business process that I ran, you would see it, but you would see it as a separate line item. We do manage like the technical correlation separately, even though the business ID could be the same.
Okay. We have a whole lot of other questions here, so I'll ask you to just jump on chat and starting chat with people after that, Kent. But let's first, thank you very much. You see, for the number of questions, a lot of people are super interested on that. But I think it's now time to change tack and bring our friends from Service Bus. So let me add Christina to the stage and add Mr. Eldert. Right, so get those ready to go. Is all yours, and enjoy, everyone. Know that it's going to be interesting.
Thanks so much. Thank you, Wagner. So, Christina, do you want to introduce yourself first?
I'm Christina. Christina Compy. I am lead PM in the messaging team. You may know of me, if you do know of me, from the app service team, where I used to work on a variety of networking things.
Thank you. Yeah, I'm Grootenboer. I'm the project manager for Azure Service Bus. And so today we are going to show you a bit about Service Bus and Event Hubs, our innovation for today and tomorrow. So what can you expect today? We will be sharing about a quick overview of what is Azure Service Bus and what is Azure Event Hubs, the differentiation between those two services. So we get a lot of questions around this from our customers. When should I be using which service? How do they compare to each other? So we're going to talk about that. We are going to run over our recent releases. We are going to give you a bit of insights in our upcoming features and a bit of an insight in our roadmap. So let's start with a quick overview. So before we start into the service themselves, we first have to understand what there's quite different kind of messages. So this is why we have these different services. So we have, of course, Event Grid there as well, which we won't talk about today, but it's definitely also one of our very important services. But when we look at messages, we can basically distinguish in these kind of messages and many more. I won't go through all of them, but just call out a few of these. For example, a command: I want you to do something for me. I'm expecting you to do something. I don't know who's going to do this, but there's someone out there that's going to do something for me. Or a request: get me some data, do this, get me some of information. On the other side, we also have, for example, notifications, which tell more about, hey, something has happened. And so if we set these aside, then basically we can distinguish between intents, where I want something to happen, I'm expecting something to do something for me, versus information, which is more about, this is what happened, and someone might be interested in this, but it's not part of my specific workload. And this basically difference between messaging and eventing. And eventing we see as a subtype of messaging. And this is already a very important distinction, because messaging is really about the intent to do something for me. Eventing is really about the information. Now, if you look a bit deeper into events, we can also distinguish two types of events here. So first of all, we have discrete events. So discrete events are basically independent of each other. So they stand on their own. They report a state change. So, for example, a blob was uploaded, an invoice was created. So some kind of state that has changed. And they are actionable. So when something happened, I might want to do something. And so, for example, a blob was uploaded. When a blob was uploaded, I might want to resize an image that was uploaded. Or I might want to start an OCR run. If an invoice was uploaded, I might want to then send out an email to someone. But so these are really discrete events. They're on their own. They are not part of a larger stream, which is the other type of event that we have. So stream is time-ordered events. So they're part of a larger stream. So they all come together and they are ordered in time. They are petitioned on a certain context. So there might, for example, be they are petitioned on a device ID. They might be petitioned on an order ID. But there's some kind of context that they are petitioned on. They report a condition. This is my current state. So for example, the current temperature is X, or my car is at this location now. So they report a condition. And you can analyze these events in a stream. So over time, you can see what happened to your data. So you might be able to see how the temperature change over time. Where is my car that's driving around? So those are different kind of messages and events that we have. And that's really important to understand why we have these different services. So I will talk a bit about what are the different services. And like I said, today we are going to focus on Service Bus and Event Hubs. Event Grid will have their own sessions, so definitely also watch those if you want to know more about Event Grid. But let's start with Azure Service Bus to explain a bit about what is this service. So what's Azure Service Bus? Azure Service Bus is basically like a post office. You have a producer, something that communicates data, that wants to communicate data between different software systems. And then within the post office, within Service Bus, you can receive those messages, route them, and publish them. The systems don't need to know about each other. So the consumer doesn't actually have to know about the producer. They don't ever have to meet because they have this post office, or in our case, Service Bus, in between. And you can now easily add, remove, or change parts of the system without disrupting your whole environment. So if any part of your system needs to be changed, you only have to change that one connection instead of having, which you see with the spaghetti architecture, as we call it, where everything is connected to each other. Then when you have to change one system, all the systems are exchanging data with the system has to be changed. Once you put something like Service Bus in the middle, you can basically do this without any disruptions. So Service Bus is really about enterprise messaging as a service. So first of all, it's about that messaging, about those intents. So Service Bus is a platform as a service. So we host this for you. You just write your scenarios and your application in there. It has queues and topics. And so queue is basically, you put something into a queue as a producer. You have a consumer that picks the message out of the queue. Each message goes to one consumer. The consumer then processes the message and either completes it when it's successful, or it might abandon it or delete it if something happened. A message will be processed once. At least if you complete the message, it will be processed once. If you cannot complete it, then you should put it back on the queue. The next consumer will pick it up and will then consume it. But in theory, it will be processed exactly once. It allows for reliable asynchronous communication. So Service Bus, Event Hubs, we are really about reliability. We provide 4 nines of on our SLA. And we really, what is most important for us is that we guarantee you that you'll never lose a message. You can use things like message headers to set up routing. So if you can set message headers, you can use those to actually route your messages to different destinations where you're using topics or subscriptions. And actually, I now realize that I may have mentioned queues, but not topics. So topic is actually similar to a queue, where you put something into a topic, and then you can have one or multiple subscriptions. And so those subscriptions each have one or multiple subscribers again, and then each subscriber once again gets a message from their subscription. So together with those message headers, you can route messages to specific subscriptions. A message might go to all the subscriptions or only to specific ones. So basically that allows you to do that routing and filtering. And like I said, at least once, at most once, and exactly once. So depending on what kind of log mode that you use. So we have a receive and delete log mode, where basically you have it will be received by a consumer. If something happens to the message, the consumer is in control of it. So that's at most once delivery. We also have at least once delivery, where you use our peak log mode. And that's the one where you basically pick the message up and you can either abandon it or complete it. You can also do exactly once. It has a bit more effort, but you can use something on your consumer side where you can also keep track, what did I already process, and then basically restart in your process where the process might have stopped. It has a rich feature set, and I'm not going to run through all of these, but just to give you an idea of what are all the features that we provide. Here's a complete list. It's too long, like we only have 40 minutes today. We want to take your questions as well, so I won't go through all of these. But I want you to show you that Service Bus is really about that rich enterprise messaging feature set. So we basically allow you to do anything that you might need to make sure that your messages are come across with the right intent to the right places without you having to worry about this. So I do want to highlight a couple of the features of the Service Bus Premium tier. So we have 3 different tiers. We have Basic, which is basically only queues. We most often see this for maybe simple task queues or very easy test workloads. We have the standard tier, where you can go with your lighter workloads. It's pay as you go, so you only pay for the message that you send through. And we have the premium tier, where you pay per hour, and which has a lot of premium features that you might want to have for your really enterprise scenarios. So, for example, you run on dedicated resources with premium, so you actually get your own resources. We do this in the form of a messaging unit. And so messaging unit gives you some dedicated resources that are just for you. We guarantee that when you want us to use the resources, they are available to you. We also have GeoDR there. At the moment, it's just metadata GeoDR, so we replicate your queues and your topics and things like that. We are going to talk a bit more about GeoDR in a later slide, but for now, that's what we have. We also have large message support, so message up to 100 megabytes you can do in premium. JMS 2.0 compatibility, so if you are using something like IBM MQ, typical EMS, you can very easily switch to Service Bus. We have availability zones in there. So basically, availability zones allow you to have your namespace running in 3 different instances in 3 different data centers. We always have 3 instances, by the way. So we always have 3 instances. In non-availability zones regions, this will be 3 instances in the same data center. When you are using availability zones, they actually are in 3 different data centers in the same zone. So even if a complete data center goes down, we can very immediately switch over to a different data center, and you can just keep running without any impact. VNet integration, of course, where you can actually insert your service bus into a VNet and use it only from your own network. Partitioning is something that we recently released 2 weeks ago at Ignite, where you can actually have multiple partitions in Service Bus Premium, and each partition gets 1 to 16 mesh units of throughput, which basically means that you can now scale to any workload that you want. So that's Service Bus, and I hope that you understand what this is used for. It's really about the messaging, enterprise messaging scenario. Like I said, today we're also going to talk about Event Hubs, and Event Hubs is really about streaming data. So if you look at Event Hubs, basically it looks like a tape recorder. So basically it records a stream of data, so you have a lot of data that comes in, and that data comes in a stream, so one after another. So the recording, the incoming messages only move forward. So you can not say, I want to append something in the middle of the stream or something like that. Messages are always placed at the end of this stream. Now you can, of course, go back and forward over that stream. So it's similar to that tape deck once again. So if you have a stream of data, Event Hubs uses a client-side cursor, and its client-side cursor, as the name suggests, is controlled by the client. So the client can actually say, I want to read the data from the stream from this specific point in time. So you can actually go back in this time, you can go forward in time, and just play the data over from where you want. And for example, if you are using something like event sourcing, you might say, I want to replay that order from a specific point because I might have lost some data in my backend or something else. And this way you can easily go back in time and replay that. So you can replay this from anywhere. And then you can, like I said, go back and forth for this. You have multiple channels, what we call partitions. So you have multiple partitions, and your data are spread across the partitions. And let's actually talk a bit more about those partitions, because they are a very big part of our architecture. So when we look at the Event Hubs, basically we have those partitions in Event Hubs, and those partitions are where your data will land. Now, you can have many event producers, and those producers are going to send data to your partitions. You can do this using Kafka protocol, HTTP, or MQP. And so those producers are going to generate data. The data will land in one of the partitions. You can be in control of this on which partition something lands by setting a partition key. Or if you don't care about the exact order of this data, you can also do this without partition key, which gives you a bit more of throughput. On the other side, we have our event receivers. So the receivers that are interested in playing back these events. So you can have up to the total number of partitions that you have. So let's say you have 4 partitions, then you can have 1, 2, 3, or 4 consumers. Those receivers are going to listen on a consumer group. And basically a consumer group is their abstraction between those partitions and the receivers. And so those consumers are then going to listen to those partitions, and each consumer will start listening on one or multiple partitions. If we want to bring in other receivers, we can also create a second consumer group. And in this case, similar, so we have another consumer group with listens there. But the data, they are in control over themselves. Like I said, with the client-side cursor, each of these receivers has their own client-side cursor. So each of these receivers can go back in their own stream of data. The stream of data will just stay there, and they can go back in time in that stream. So for those of you that already know Kafka, you might be thinking this is a lot what Kafka is doing as well, because they both use that partition consumer. They both have those partitions that are independent of each other. They both use the client-side cursor concept. Both can scale to very high workloads. And conceptually, they are indeed the same. So that's actually why we decided to have the event hubs for Apache Kafka connector. So you can actually use your existing Kafka applications, connect them to to event hubs without changing any code. You can just connect them and it will work. So we have an endpoint that's fully compatible with Kafka. Like I said, you just change your connection string and it will work. So you can use any of your existing Kafka applications, but also the tooling that comes with Kafka. And you can use this with event hubs. So it has all the features that we are going to discuss more of these, but so it has all the features that you would expect from Kafka. So things like log compaction, Kafka compaction, Kafka Connect, mirror maker to support, JSON schema support, and schema registry. Now, another thing that we have that is really awesome, if I can say so, is Event Hubs Capture. So Event Hubs Capture allows you to batch your data stream. And what does this mean? It basically means that you can upload your that stream of data that's come in. You can upload that onto storage and then use that storage for your big data workloads. So it's based on a policy. So basically you said, I want to upload it every X minutes or every X megabytes. So for example, you can say either when I hit 5 minutes or when I hit 25 megabytes, for example, I want to create an Afro file on my storage with all the data. So you can use this kept data then as a source for your big data processing pipeline. And what's really cool about this is just a checkbox that you set. So, and imagine that we are talking about big streams that are coming in, a lot of data. And what we saw is that if our customers, when they were building themselves before we had this feature, they had a lot of performance impacts. So we decided to build this for you, so you don't have to worry about this. We give this to you in a very easy way, so that you can have both your fast stream and your slow stream, both from event hubs, without you having to think about how you do this. Another service that we have is Stream Analytics. It's not a message broker itself, but it's very closely related to event hubs. So as we are processing this very big stream of data, we need something that can handle that stream, that can handle that massive amounts of data, and that can easily bring this to where we need to go. So this is where Stream Analytics comes in. So Stream Analytics allows for real-time event stream processing. So basically, on your event hubs, you can connect your Stream Analytics, and it will start reading that stream. So it can process large volumes of streaming data. That's really what it's about, like that big pipeline of data that coming in, that big stream, that you can process this very, very easily. It has sub-millisecond latencies, so it goes really fast. And it has a nice intuitive graphical drag and drop tool that is actually built into event hubs. So actually you can go to event hubs, say that you want to process the data. It will show you a no-code, low-code experience where you can drag and drop. You set your input, you set your outputs. For example, send my data to Power BI, send my data to another event hub, send my data to Source Bus. So it's very easy to set this up and very easy to quickly get started with processing your fast data. So something that we also recently released at Ignite was Microsoft Fabric Event Streams. So event streams are event streaming offered as a SaaS. So instead of PaaS, so event hubs, Source Bus, Stream Analytics, these are PaaS services. Microsoft Fabric is actually a SaaS product that we also have event streams in. So it allows you to capture, transform, route in real time your events to various destinations with no-code experience. And this is actually powered by event hubs and Stream Analytics under the hood. So when you create one of those Microsoft Fabric event streams, we are actually creating an event hub and Stream Analytics for you and giving you all that those capabilities that we have here for you to very easily get started. So differentiation. Like I said, we get a lot of questions from our customers. I want to do some messaging or eventing. Which service do I need? I talked about what is Event Hubs now, what is Service Bus. So let's have a look and what are differentiations. So when would you use queues? You would use queues if you need a first in, first out approach. So FIFO approach. So you put something in that goes into the queue and it will be in order in the queue, guaranteed order. And so your consumers pick up every time the first message that was in the queue. It allows you to do competing consumers pattern. So you have multiple consumers and those different consumers will all compete for those messages, as we say. So basically what it means is that every consumer gets one message and they process that message. And the other consumer gets next message, the other consumer gets next message. And so that way you can have multiple consumers that are processing these messages in parallel. Guaranteed at least once or guaranteed only once. And so what it looks like is kind of like this. So we have our producers on one side, we have the queue in the middle, we have our consumers on the other side. Those producers are going to produce messages, so going to place messages on the queue, and our consumers are going to ask for the first available message. So the first message gets picked up by one consumer, the second message gets picked up by the second consumer. And of course, we can now continue this as we go with many more messages as well. Also very important here is that once a message has been acknowledged by the queue, so if your producer sends a message to the queue, gets back an acknowledgement, we will never lose that message. That message will stay there until you get it from that queue. So topics and subscriptions, the other part of Service Bus. So topics and subscriptions you would use if you want to do with multiple consumers. So we have a producer that only knows about the topic side. So a producer sends something to a topic, and you have consumers that only know about their specific subscriptions. So under subscriptions, you can have filters and actions. So filter allows you to say, I only want to receive this specific subset of messages. An action you can use to actually update your metadata, the message headers. And that way you can also chain things together. So what does this look like? Once again, we have producers, we have consumers. In this case, we have a topic. On the topic, we might have a filter. So in this case, we have 3 subscriptions. So the first subscription has a filter of type equals order. The second subscription has a filter of type equals quote. And the third subscription has a filter of type equals order or quote. Now, as we are starting to send messages, so we have one producer that's going to send order messages, one producer that's going to send quote messages. And so the order message will end up in both subscription A and subscription C. And the quote messages will end up in both subscriptions B and subscription C. So this is where you would use queues and topics. Where would you use streams? Streams if you want to do that real-time data streaming. So if you have a large suite of real-time data that you want to process. Like I said, it supports Apache Kafka workloads, so you can easily move those over as well. And it's really about high volume throughput with very low latency. And so it basically is like a fire hose. So you have consumers that want to have like that stream of data. You have event hubs, and you have a producer that is going to create that big stream of data, big stream of messages, big stream of events. So stream processing, of course, as well. Like I said, often when you want to have that stream of data, you want to process that data in an easy way. So that's where Event Hubs plus Azure Stream Analytics comes in to do real-time event stream processing. So it allows you to process large volumes of the data very easily with sub-millisecond latencies and use that no-code drag and drop editor that's built into Event Hubs. And so basically this looks very much, of course, like Event Hubs. So it's Event Hubs plus Stream Analytics. And so you once again get that big stream of data in. Stream Analytics is going to process the data. It's going to do your analysis over this. And it's going to push this to your consumers. So if we look at Azure Message Platform, like I said, so Azure Service Bus is really about connecting apps on an enterprise messaging, queuing, and PubSub platform using open protocols, so including JMS 2.0. Azure Event Grid, which we'll hear more about later in this conference, is about publishing and subscribing to MQTT messages and HTTP push and pull for delivery of discrete events. So Service Bus is about messaging, Event Grid, discrete eventing, and Event Hubs is about cloud scale low latency streaming platform supporting Apache Kafka and AMQP client services, so streaming events. And of course, Stream Analytics to make it really easy to process the events in Event Hubs. So the real-time stream processing and the analytics engine with rich development tools and low-code, no-code editor experience. Now, 75% of our S500 customers use 2 or more of these mesh brokers. And that's important to understand. So this is what this was about, or this is about the differentiation. These are 3 different kind of scenarios that you want to implement with this. Don't be afraid to say, I'm going to spin up both a Service Bus and an Event Grid, or a Service Bus and Event Hubs, or even all 3 of them. Pick the ones that you need. Look at your scenario, pick what fits your scenario. Also, open protocols are really important for us. We are very much involved within these protocols to make sure that we adhere to them. We even help them design some of these. So we have support for cloud events on Azure Event Grid. We have support for MQP on Service Bus and Event Hubs. We have support for MQTT on Event Grid. We have support for Kafka on Event Hubs. And we have support for JMS on Service Bus. So that was already a lot of information about what is Event Hubs and what is Service Bus. So I hope you have a better understanding now when would you use which. Now, the second part of this session, we want to talk about what are we building? What have we built? What are we building? So basically, I want to give you some insights into what is the things that we think that you might need, and please give us feedback on this. Like, give us feedback, what we released, if you like this, what you might want to see improved. On what we are building, let us know the scenarios this is going to solve for you. For us, it's really important to get your feedback because in the end, we are building this for you. So we want to make sure that what we are building is what you want. So first of all, passwordless authentication for JMS. So we already have password authentication on our Service Bus API for quite some time, where you can use managed identity or Service Principal and use that to connect to your Service Bus. However, about 6 months ago, I think, Ability also released password authentication for JMS. So if you are using JMS with Service Bus, you can now also use your managed identities and Service Principals there. Of course, this is all backed by Enter ID for authentication. And as you can see here, it's really easy to get to connect your application to that managed identity, get your token, and use that to authenticate with us. So we also have 2 performance features. So the first one is consistent low latency on your entities. And we are basically doing this by moving to a new storage provider. We used to run all our storage on Azure Storage. However, sometimes what we would get is we had a minor network glitch, storage might have a minor blip, but once you are talking about 40 or 50 milliseconds of P99 latency, anything that hits you will immediately be a big hit. So we are now actually moving to a multi-tier storage, where we first go to our local storage on Service Fabric, and then offload on Azure Storage as needed. By this, we greatly improve our reliability because we are no longer dependent on Azure Storage, on the network or anything like that. We just go directly to our own local storage. And also we are bringing down our latency from 40 to 50 milliseconds P99 to about 35 milliseconds P99. The second performance feature that so by the way, consistent low latency entities is currently public preview. You don't have to do anything for this. You automatically get onboarded on this. And actually, let me go back one step. This is part of a much larger investment that we are doing on our underlying platform. So we are moving from cloud services to VMSSS. And so as we are onboarding all our customers on VMSSS, you automatically get this feature. And it's on the premium tier. And so on the premium tier, you automatically get this feature as we are moving you to this new infrastructure. Everyone will be moved to this new infrastructure by next year. And so at some point, we are already in the process of migrating you. So if you see a nice drop in your latency, this is what has happened. The second feature that we have released, and this is actually now in GA, is partition namespaces for premium. So on the premium tier, you can also create partition namespaces. We already had partition namespaces on standard, although they work quite a bit different. On standard, where you say that your namespace is partitioned, we automatically create 16 partitions for you, and your messages are spread across those. For premium, however, you specify how many partitions that you want. And with those partitions, you can now scale higher than you could do previously. So up until now, you could basically scale from 1 to 16 message units. And on each message unit, you can get about 2,000 to 4,000 messages per second or 2 to 4 megabytes per second, depending on which features you are using, how your workload is actually looking. But let's say that's about the baseline that you can get. Now, because we had a limit of 16 message units, that would mean that at some point, maybe about 60,000 messages per second, something like that, you would start hitting that limit. You could not scale any further. And so we had customers coming to us. We want to scale 100,000 messages per second, 150,000 messages per second. How can we do this? So we introduced this new feature where you can now create petitions on your premium namespaces. And each petition gets 1 to 6 message units. So let's say that you create a namespace with 4 petitions. That means that you can now scale from 4 to 64 message units. Is even not enough for you? This is not the hard limit. We have currently chosen this limit because we don't see our customers that need more. But it's not a hard limit. We can increase this limit even if you want to. So please, if you have a higher limit than 4 petitions, reach out to us and we can help you with this. Do note that this is really for high throughput scenarios where absolute order and message distribution is less important. Because we are now using petitions, messages basically go to a random petition. So similar to event hubs, as I explained, a message go to a random petition unless you specify a petition key, or if you use sessions, which basically allows you to process the messages with the same session ID by the same consumer. So, of course, you can still do this. So messages can definitely go to the same petition if they need to be able to stay together. However, it does give you a small impact on the performance. And like I said, this feature is really about the highest performance. So if you don't need it, don't enable it, but you can if you do need it. So the relative order is still preserved. So messages in the same petition are still in order. And like I said, you can use petition keys or sessions to enforce that order. Christina, do you want to talk about this part?
Sure. I'll jump in on compaction. So we recently released log compaction for event hubs. This allows you to retain the latest version, latest copy of a message with the same key. This is useful for taking up less space, ensuring you're using the last record, and a number of other things. It was also required for some other features we were building. This is available for our standard premium dedicated tiers, not in basic, but you should use basic anyhow. Rather have you in standard. Yes, come to us. And then let's see, what else could I say about that? That's fine. Next item.
Yep. Kafka Connect.
Kafka Connect. So we added the ability for you to use Kafka Connect to basically take advantage of the vast pool of connectors that are available. This interacts cleanly with event hubs. You don't have to do anything different than you would with a normal Kafka deployment. And it works nicely also with the event hub schema registry, as it's pointed out.
Yes. Mirror Maker.
Mirror Maker 2. I don't know if you guys have ever used Mirror Maker 1. Show of hands, who's used Mirror Maker 1? Yeah, live performances are better in person. But Mirror Maker 1 was nowhere near as good as Mirror Maker 2. Mirror Maker 2 supports far greater traffic loads, and we were happy to be able to announce support earlier this year. This will allow you to basically seamlessly connect to Kafka clusters. So if you wanted to wire up your on-prem Kafka system and have it feed your Event Hubs cluster, boom, Mirror Maker 2. If you wanted to move from, we'll just say, another service that runs Kafka and move your data over to Event Hubs, this is the way to go. And it's great for migration purposes as well as just normal runtime. Supports offset replication. It supports basically replication however you want to go about it, whether it's migration or runtime. Fire away. Next one. JSON schema support. So this capability is in preview. Previously, we just had Avro support, which is pretty similar, but we had Avro support in the schema registry, and right now we've got JSON schema in preview. Please try it out. If you have any feedback, let us know. This lets you easily share your schema between your producers and consumers, making your overall experience far cleaner. Yeah, right? Mirror Maker 2 is great, isn't it? Well, Mirror Maker 2. Mirror Maker 1, I like Mirror Maker too. You may have picked up an undertone of passion. So next one, what do we got?
There we go.
Data generator for Event Hub. So I love this feature. It's still in preview, and I'll tell you why later when we talk about what's upcoming. But the data generator for Event Hubs lets you actually send in sample data to your Event Hub. You no longer have to code up an application just to test drive data into your system. So if you wanted to learn, do a demo, just exercise your system to see how it works end to end, the data generator is a really slick tool. Event Service Bus has had the edge for a while with their own Explorer and data generator experience. And so, now we have Event Hubs catching up a bit. Next one. Manage identity for capture. So this is a big deal. So we used to have capture, as Eldert went into. Capture is a fantastic feature. And the small gap was you didn't have the ability to use managed identities with it. Now, as we all know, doing the managed identity intro auth stuff is just a far more secure method than just using a simple password, SAS key, etc. So this adds security to your overall system. You avoid the problem of wandering SAS keys, and it basically also lets you pass compliance audits.
Yes.
Great feature. I love this.
Yes.
Coming
So
soon.
next part, yes. So next part is what is coming soon. And when we say coming soon, this is basically what we hope to release in the first half of next year. Of course, this is all under the disclaimer that this is in development. Things might not go as we were expecting initially, but this is basically what we want to have released in the first half of next year. Now, I do know we only have 5 minutes left, so we will go to this quick, but we just have way too much things that we are releasing. So, but first of all, geodata replication. So this is something that we are actually building both for Service Bus and Event Hubs. Both of them are currently in private preview. So the new geodata replication, like I said, we already support geodata replication in Service Bus, for example, for the metadata, but not for the messages in there. So with the new geodata replication, we are going to full data replication across multiple regions. You will create a namespace. You'll say where your primary is, where your secondaries are. You can use synchronous and asynchronous replication, where synchronous replication basically means you send something to the client, to the service. We commit it on the primary. We sync it to the secondary. We wait for the answer on the secondary. Once committed to a quorum of secondaries, then we send back the acknowledgement. RPO 0, no data will ever be lost. Of course, some added latency. Asynchronous replication, on the other hand, you send it to the primary, we commit it on the primary, we give back the acknowledgement, so same as today, and then we start replicating your data. So synchronous replication is your RPO 0. Asynchronous replication, you will set your RPO. You are in control of this, so you can set, for example, say my RPO is 10 minutes, and we will make sure that once you hit that 10-minute replication lag, then we start throttling incoming requests, so you will never lose more data than you are allowed to. You will be doing a manual failover, but we'll give you telemetry to automate this. You are in control of that failover. You will know when you want to failover normally. You also might want to fail over other parts of your application. So we give you the telemetry so that you can automate this, but you will be in control of this. And like I said, releasing for both Event Hubs and Service Bus. On Service Bus, we also have durable terminus. So durable terminus basically allows you to survive connection breaks. So as we are going more toward containers, distributed systems, instead of having everything nicely in one data center, things are now spread all over. And so what happens at that moment is that your connection might break for some reasons. It might be because a container got restarted, a network hiccup, we are doing maintenance on your cluster, but for whatever reason, your connection might break. And at that moment, you also have a link breaks between your client and the service. Now, when the link breaks at this moment, you lose your mesh state, a message becomes available again on the queue. Next consumer picks it up, and the message might be processed twice. So what we are going to do instead with durable terminus is introduce a new lock mode. Currently, it's called durable lock. Might still change depending on feedback in the private preview. But with that new lock mode, you basically can say, I want to keep a lock on this message, and don't release the lock until I say it to. So even if your connection breaks, you will just reconnect. If you are using our SDKs, it will all happen automatically for you. He will just reconnect saying, hey, I'm back again. Please give me back my message state. And this way, you can have one consumer that is completely locked into that one message. So no more messages that are being posted twice because of connection breaks. No more need for renewal of logs. It's just yours. Delayed abandon. So basically allowing you to place a message at the back of an entity with a delay. So you don't need send permissions. You only need to receive permissions. And reschedule message will be placed at the back of the entity. And I do see that we are almost at time, so I will start going a bit quicker to those. These are smaller features, so we can go a bit quicker to those. If you have any specific questions about any of these, by the way, please let us know in the questions, and we will happily answer those. Batch delete, allowing you to delete messages in batches, up to 4,000 messages per batch. So it will be improved performance over receive and delete. You no longer have to receive message. We will actually do this server side. Peak message by state, being able to say, I only want to see the message in an active state or in a scheduled state. And this basically allows you to do better scaling with functions and with KIDA. Christina, can you
Kafka transactions. So we've got two gaps within our Kafka support. One is lack of support for Kafka transactions. We're working on that. Next one, I'm going to go light speed here. Kafka streams, bingo. So we're working on both of those. Next one. Data Explorer. This is the one that I was the connection back with the data generator. So we're going to put them out together so you can generate data and see your data, which is like fantastic. Just like what you could do with Service Bus. We'll be adding that to Event Hubs. Next. Large message. You can have big messages. Next. Protobuf supported in schema registries. So we've got Jason and Avro. We'll be adding Protobuf. So that's cool. Rounds out the essential need. Roadmap. We're at time. Nobody gets to know what the roadmap is. Yeah, there's only 2 quick items.
Yes. So first of all,
just for information, Clemens and Kevin are on the chat and answering questions like crazy. So the most of the questions that we had for you, it was a lot of them. They already answered. So feel free to get those last 5 minutes for questions to go through roadmap and stuff.
Yeah.
Perfect. Then we can talk a bit about the local emulator. And I can actually hear people cheering outside right now. So the local emulator, the thing that everyone has been asking for, we are building it. So yes, we are building this both for Event Hubs and Service Bus. So Event Hubs, hopefully beginning of next year, Service Bus probably end of next year. Of course, this is actually roadmap stuff. This is definitely not a guarantee. It will be there at that moment. Let me make that very clear. But just give you at least some indication of what we are hoping for. It will be a containerized version of the of Service Bus and Event Hubs. You can run it cross-platform. It will work on Linux. It will run in a container, so you can run this on your local machine. You can run this in your test pipelines, and it will have all the functionality that makes sense for a dev test environment. Now, for example, for Service Bus, what that means is, yes, you will definitely get queues and topics. No, you will definitely not get GeoDR. Then there's a whole slew of features in between, and we are going to figure out what are the features that make sense for a dev test scenario, and what are features that would make sense to actually just keep on the surface. Please let us know what you need here. If you have specific scenarios, let us know them, so we can see, okay, what are we going to include? And like I said, releasing for both Event Hubs and Service Bus, with Event Hubs coming first and Service Bus coming next. Subscription metrics. So another ask that we get a lot is that our customers want to know our customers want to know what happens in their subscriptions. So for our topics have can have up to 2,000 subscriptions. So let's say that you have 16 machine units. Each machine unit can have 1,000 topics. Each topic can have 2,000 subscriptions. There's a lot of metrics that are being generated there. And so at the moment we cannot push this to our MDM system because they will actually start falling over. So we are now going to first push our subscription metrics into Log Analytics. Later on, so this will be very much out on the roadmap. At some point, we'll have premium metrics that we can hook into. But for now, we are going to do this with Log Analytics. We'll push those metrics into your Log Analytics from your subscriptions. And you can then use Kusto, etc. to create alerts, create dashboards, and things like that. And with that, we're almost done. So quick takeaways. Of course, identify the scenario that you're working on. Make sure you're using the right service. Make sure that you're using the right features. If you have any questions around this, there's a lot of help, of course, from our community, but also from us. If you feel like something is missing, let us know. Use those services in conjunction with each other. Our services complement each other. You don't have to choose one. You can actually use multiple. Like I said, you can have a stream of data coming into Event Hubs. Have your stream analytics, process that stream, and then send specific messages to Service Bus for actually start taking actions. So they actually work very nicely together. So also make sure that you take care of that capability. And once again, provide your feedback. There's Azure IDs that's out there. There's GitHub. There's other places. Please provide us your feedback. Azure IDs is actually, or Azure feedback. I don't know what to call it these days. I think it's Azure IDs. Use that because that's most important, where you can actually upvote other people's initiatives, or you can put in your own. I look at that every week to see what you are requesting from us. And we actually use this every time that we are planning our backlog. We use this to make sure that what we are planning is actually what is being asked for. So with that, thank you. And let's see if Wagner has any questions remaining for us.
There was a question on, can they look to search on a unique key in the Service Bus Explorer in the dead letter queue?
For Service Bus Explorer, search for a specific key is not something that we support today. It's something that we do support on the JMS API actually. So on the JMS API, you can actually say, I want to apply a specific selector. So that works. If this is something that you would like to have on the normal Service Bus API, so to say, our default API as well, please put in the support the feature request, and we'll definitely look into this.
And I think I came back just in time. I totally lost audio halfway through, right? Probably when you guys hear waiting for device to connect.
Yes, I hear that.
Yeah. So I'll pass it on to, I think it's like pretty much all the questions that we had on the chat is being answered by Kevin and Clemens, right? So
Awesome.
With
that was me, actually.
Yeah, Azure messaging.
Yeah.
Oh, cool. I thought that was Clemens. So that's good.
Nah.
That's good also. So come on, turn it off. There we go. So in this case, thanks, Christina, for all the answers, and thanks, Eldert, for the presentation. As we see, like there's
Yes,
a lot
thank you.
of interest of everything that we have in here. But now we are 1 minute late. So
Sorry.
yeah, it's good. So
we
with
ran
that, bring in Alex to introduce Roberto, and we should be ready to go. Just let me find.
Yeah, thank you to the Service Bus team. Next up, we've got what's new on Azure Event Grid with Roberto.
Awesome.
So feel free to take it away for us, Roberto. Very excited to hear what you got for us.
Awesome. Can you hear me well? Actually?
Yes.
Awesome. That's great. Well, thank you for the invite. Let's talk today about what's new on Azure Event Grid. Let me introduce myself. I'm Roberto Cervantes, one of the PMs for Azure Event Grid. I'm a senior PM in the team. And let's start with the agenda. What we're going to see today is a quick overview about what's Event Grid, what are the new features that we are providing in the service. We have push delivery, pull delivery. The MQTT broker is something new that maybe you will discover today, and the recent announcements. This is part of the agenda. Event Grid. What is Event Grid? In general, Event Grid is an elastic pops-up message broker. In the past, we were focused just only in push delivery. This is one of the common patterns that you may see when we talk about event-driven. But now we have been evolving the service. In these scenarios, we will see in this diagram that we have support to multiple protocols and multiple messaging patterns. It means that now we can support push and pull. And with pull delivery, we are opening new scenarios that we will talk later. as you may know, Event Grid has multiple resources. Is at some point we have many resources that were created to satisfy a particular use case. We have system topic, custom topics, domains, partner topics. All this is a family of the Event Grid in the past, was a family. And one thing that we are doing today is that we are consolidating all these resources as the basic tier. And what you are going to hear more about basic tier, because we are introducing a new resource that is part of a new capability and a new tier. Event Grid Basic is almost everything that you have been using in the past. With Event Grid, you have been consuming events from a particular storage, from a system source, from your custom applications. You have been doing filtering, delivery retry, that lettering. You have been using functions or webhooks for your own applications. So in general, this is what we have in the past with Event Grid. But now with Event Grid, we have been developing or re-engineering the broker to offer more. And what we want to offer in this new resource, that is the Event Grid namespace. First of all, let me explain what is an Event Grid namespace. Event Grid namespace is a logical container for multiple and flexible topics, where you can create multiple and flexible subscriptions too. And this is interesting because in the past, we just have one resource, one particular subscription type, and now we can create more things in each one of the topics and the subscriptions. For example, if you see the topology that we have here, we have eventing, that is all the namespace topics. With the subscriptions, you can create a namespace topic, and you can, inside of the namespace topic, you can create as many subscriptions you need, and you can create subscriptions now focus on push or focus on pull. We will see a demo later about how it works. And by other hand, we have the MQTT broker. And you may say, well, why you have MQTT broker? Event Grid is jumping into the IoT space. And what we want is to start having other scenarios, not only for eventing, but also for IoT devices. One thing that we would like to do here is to offer the same capabilities that we have in the past. For example, when you create a subscription, you can route or you can forward events to a function or service bus or an event hub, and you can create powerful streaming pipelines with, for example, with the event hubs. Now, one of the capabilities that we are offering also in MQTT, aside of the bidirectional communication, is the routing of the messages. Let's see more about MQTT later. Some of the features that or the sub-resources that we have in MQTT are the topic spaces, where we have dynamic templates. We have clients where you are going to register devices. You can have 1 or million of devices. We can group those devices in client groups. We can add certificates for validation authorization. And we have permission bindings where we can identify the group as a publisher or consumer. In general, all these capabilities are part of the new standard tier. This is where Event Grid is evolving, and we are doing more things than a traditional event broker. We have now the flexible consumption, which push and pull. We have higher throughput, and this is something that you are going to see in a moment with another slide, where we are increasing the throughput, the ingress and egress rates. So in general, there was a standard for 5 megabytes per ingress and egress in Event Grid basic resources, but now we are increasing this to 40 megabytes per ingress and 80 megabytes per egress. So another important feature that we're introducing is the private link support for egress using pool delivery. What it means that in the past, we received many questions about how can we consume or deliver events to a private destinations. So now we are enabling this capability using private link support in pool delivery. As I mentioned it before, for MQTT, we are supporting MQTT 3.1.1 version 5, and other MQTT capabilities that as the routing MQTT messages, the one that I mentioned before, where you can imagine that you have a device and the device is sending messages to Event Grid, and Event Grid is replying those messages to the device. But aside of that bidirectional communication, you can take that message and route it to an additional workload or a stream process that you have. So you can connect those messages to another functionality. And this is where the things come interesting. This is part of the evolution of Event Grid. You will see in this table that we have several features listed. For example, as I mentioned it, we have a huge increase on throughput. This is part of the improvement that we have been doing in the broker. We are supporting now the MQTT broker, pull delivery capabilities, publish. One thing that we did, and this is part of the things that we are introducing also, is push delivery. It means that the namespace will be supporting push and pull, but push delivery right now is just supporting event hubs in namespaces. In the future, we expect to support more destinations, but right now we are just sending events to event hubs. And another important aspect that you will see here is the retention that we are providing to the events in the broker. We are increasing from 1 day in basic to 7 days in a standard tier. So this is part of the improvement that we are doing. Another one, well, in general, what you will see below is all the features that we are providing in other services like system topic, custom topics, domains, and partner topics that you may be familiarized. Let's talk about push and pull. This is interesting. We announced in Ignite that pull delivery is general available. Right now, we are offering capabilities to pull with HTTP. You can control your own event states on demand. We will see a demo in a moment about what is this. And one thing that is interesting for these scenarios is that you can control those states, and you can, as I mentioned it before, we can provide consumption from private destinations. What are the event states? The event states are the states that will allow us to manage the event once the consumer pick the message. Imagine that I successfully process the message. Well, I'm going to acknowledge the message. If I have any problem with the consumer and I need to return, I need to reprocess this event, we can return the event to the queue or to the process, to the subscription, and it's going to be picked again by other consumer. And if we don't want that the event will be processed again, we can reject the message. And this is interesting because one thing that you may be asking is, okay, you are talking me about event-driven, but you are talking me about events, but now you're talking about queuing. This is interesting. We are not planning to compete at some point with Service Bus. What we are doing is we are offering more capabilities in an event broker. At the end of the day, what you are looking here are discrete events. So this is important where you, as if you are building an application that you need to consume discrete events, you can use these new capabilities. Another feature that we launched and is currently public preview is the push delivery to event hubs. What we are doing with push delivery to event hubs is that we allow, as you may use it before, we allow to send events directly from Event Grid to event hubs, providing the traditional capabilities that we had before, like filtering, delivery retry, that lettering. But there's one interesting feature that we introduced this time, that is the support for binary mode. We have been using in the past cloud events, but now that we have fully support for cloud events, we are now supporting binary mode. This allows to publishers to send messages or events without modifying the message body. We can set whatever we want to send in binary. And this is part of the interesting approach that we are taking in order to allow publishers to send events to Event Grid. you have here about these features. As you see, there are many things that have been changing in Event Grid. We are evolving, and one thing that you may ask, well, I'm interested to use Event Grid namespace, but I don't want to create or change my current workload. Well, what you can do is you can use this feature. This is a destination in Event Grid Basic, where you can take the messages and you can route directly to a particular namespace. So you can create a subscription, and with this subscription, you can create a particular Event Grid destination with a namespace topic, and you can forward all the events to this namespace. This will allows you to start using and migrating gradually all the workflows that you have, and you can start using pool delivery capabilities without modifying your current architecture. Let's see a demo about this. What I have here, let me show you. What I have here is a namespace. This is the resource that I previously created. In general, the namespace has some particular resources. Let me refresh the website. Okay. And what you will see here, I have my namespace. My namespace was created. I already created the namespace. I have my topics, and I have the MQTT broker features. At this point, I go into eventing. I select the topics. I can select the topic that I previously created. This is a topic for custom events. And now that I'm in the topic, I can create a new subscription. A difference of the previous Event Grid resources, we can select the kind of delivery mode that we want to use. We can use queue, or we can use push. In this scenario, we are using queue and push. And what you are looking here in the subscriptions is that I have one subscription for each one of the scenarios. Now, what you are going to see in this scenario? What I'm covering is, imagine that we have a publisher, and this publisher is sending messages to an Event Grid namespace. This Event Grid namespace has a push subscription to event hubs, and at the same time has a pull subscription to let a consumer to start pulling from Event Grid. We have two different scenarios covered in one single workflow. And with this scenario that I'm showing here, now we can go directly to an application. I can show you this application. Give me just 1 second. It's here. And this application that you are looking here is going to start sending events to Event Grid. What I'm doing here is that I'm start sending events to Event Grid, and I'm going to start consuming those events from different scenarios. If you see in the left side, we have the push subscriptions that are landing in the client using push delivery, but in the right side we have pull delivery with each one of the states. What I'm doing here is that I'm coloring each one of the states, and you will see how the event is received, is acknowledged, or is released and is returned to the broker, or is rejected and is disposed. This is one of the scenarios that you can see how now with one single resource we can do both kind of messaging patterns, and we can have more retention capabilities and ingress and egress rates. Okay, let's go with MQTT. With MQTT, Azure Event Grid MQTT is one of the new and major features in Event Grid namespaces. What we are offering now is the possibility to integrate applications with this new protocol in Event Grid. It's not new, but what we are doing is we are offering custom topics. That is the possibility to use templates. We can use templates. We can use multiple messaging models. We can do one-to-one, device-to-device, one-to-many. We have many-to-one, and we can use different services for routing at some point. Let me show you some of the scenarios that I'm referring. One of the first one that you are looking here, imagine that we have several devices, and those devices are sending information to Event Grid. those messages are landing to event grid, and event grid is taking those messages and is using a topic template that is a template that we're using here in the custom topic. In the topic, we can put this wildcard, and with this wildcard, we can send all the device info telemetry to one single application. This is one scenario that we have. And the other scenario that we have here is how can we control using one-to-one, that is more like a bidirectional communication between one application to event grid. We can respond using MQTT. And at the same time, event grid can send this communication to another device and receive information from the device. This is part of the interactions. Another scenarios that we are covering here is the possibility to let one application, one cloud applications, to start sending information. Imagine that we have this particular scenario where we have alerts for failure in a particular area, and we are sending this information to event grid, and we can segregate that into a particular devices. So if we have information that is produced by one application, we can send that information to multiple devices by specifying the wildcard in the definition of the topic template. And if we want to use MQTT broker and connect the MQTT broker with the capabilities of event grid itself, the nature of event grid, we can do messaging routing. That it means that we can receive messages from devices, and we can take a copy from that message and send it to a particular topic and connect the topic with another resources using the subscriptions. We can do push, we can do pull, and we can use other kind of resources like you are looking here. These scenarios that you are looking here is because we are supporting namespace topic, and we are supporting custom topic from event grid basic tier. So in general, what we have been doing, we announced in November the general availability of MQTT. We have new ingress and egress throughput, the routing to namespace topic. And for namespace topics, we have several improvements, like the pull delivery, ingress and egress throughput. We have private link support. We have 7-day retention. We have the public preview of new capabilities like cloud events, binary mode, push subscription to event hubs, and the namespace topic as a destination for all the event grid basic resources like custom system and partner topics. This is part of the new capabilities. And to finish, we have also one of the most important integrations in system topics, that is Azure Resource Notifications. We are introducing or we are onboarded a new system topic. If you are aware about what is a system topics is one of the resources that that event grid has to consume and subscribe to event or system events notifications from other resources. We have Azure Resource Notifications, where we are receiving information from the Azure resources. Imagine that you have a virtual machine, and you need to have a particular complete information about the payload, and so you can subscribe and filter and have a more accurate information about what is happening in the virtual machine. So this is part of the new onboarded services that we have in Event Grid. If you go to system topics, you can create a new system topic with this kind of source. And well, thank you for the invite. I would like to hear the survey. If you have any questions, please let us know. I will appreciate if you can fill the survey. Part of all these features is because we are building products for you, and we would like to hear from you. What do you think about this? If there's any particular interest, we are open to hear more. And Wagner, thank you. Please.
You're welcome. You're welcome. Just like in looking at some of the questions that we have here again, Christina and Javier were super active on the chat, right? So I don't think there is any questions that not being answered. But I think it's like just for you to give your view on that as well. one of the questions from, or actually a comment from Eitaha was that he thought that the EG key differentiator was the push consumption model. And I think you touched that a little bit during the presentation, but just to add a bit more on that, feel free to add your comments on this.
Yeah, for push delivery to event hubs is what you mean?
Yes.
In general, what we are doing is that eventually we want to bring all the destinations that we have, or at least the majority of the destinations that we have in Event Grid basic resources. But one thing that we would like to do is prioritize. At this moment, what we prioritize is event hubs. We believe that there's a lot of potential by aggregating, adding event hubs to the destination. In the future, we will be adding more and more. The only advantage that you will take having this push delivery to event hubs at the difference from the previous one that we have in Event Grid Basic is that we are offering higher ingress and egress rates. With this, event is able to manage more throughput in the process.
Yeah, and I think that was also a comment in relation to introducing the pool model as well. As you said, it's not a competition with Service Bus, it's actually for a different set of scenarios.
Yes, correct. It's a different set of scenarios, and what we wanted to offer is an event broker with more capabilities than a traditional event broker.
Cool. And just a shout out for private links egress, like people really enjoy that. Right?
That's awesome.
Yeah, and I think that's it. That's all the questions that I have. Our next one is supposed to start at 1 p.m. PST. So we're going to give like a little break. I know there's like some of people is here for now almost 3 hours. So we're going to do a little break and come just before 1 p.m. to start with Mike. And Mike, before we go, if you wanted to come and say hi quickly, we can start it at 1 p.m. I'll just add you to the stage.
Yeah, hi everyone. I'm excited to talk about API management in just 10 minutes. So please enjoy your break and we'll meet very soon.
Awesome. So see you all in 10 minutes at the top of the hour.
All right, welcome back everyone to our Azure Integration Services Day. So I'm going to be passing this off to Mike to give us a little chat about API management.
Thank you, Alex. My name is Mike Budzynski. I'm a Senior Product Manager for Azure API Management. I hope we have API Management fans or at least users in the chat. So if you have ever used API Management, let us know and also keep the questions coming. So today we'll talk about a few topics. First, we'll dive deeper into the recently released features of Azure API Management. That includes pricing tiers v2, Defender for APIs, support for gRPC OData APIs, Microsoft Copilot, and Credential Manager. And then we'll wrap it up with the benefits of using Azure API Management with OpenAI APIs and some tips and tricks for practical use cases. So I'll hand it over to my colleague Fernando Mejia to talk about the pricing tiers.
Thank you, Mike. Can you hear me there?
Yeah, we can
Yeah,
hear you.
perfect. So hello, everyone. So we have just introduced new pricing tiers, but these new pricing tiers come with new exciting features and quality of life improvements that you have asked for a long time. Basically, we're going to introduce, we introduced 2 tiers in public preview in the last month, basic V2 preview. So this tier is, it will have the developer portal, basic APIs, API policies, and everything that you know and love. One difference here is that it will have some kind of VNet, in this case, private link. We also have the standard V2, and I think this new tier is the main highlight because it will have all the features that normally were in the premium tier, like VNet integration, private link, availability zones, multi-region, and also self-hosted gateway. This
Fernando, you're muted.
Can you hear me now?
Yes.
Oh, sorry, yeah. So standard V2, I would say, is the main highlight, which introduced cheaper VNet for you. And also for the next year, we're going to introduce the premium V2, which also will have VNet injection, which is going to be enhanced. You don't need to open the traffic, the network security groups to our own dependencies for API management, so it will be easier to use. And of course, it will have the most performance of all the new tiers. Some limitations and considerations that you have to be aware is that these new tiers are only available in a subset of regions. Also, some of these new tiers will contain a cap, a limit on the number of API requests that you can do, except for Premium V2. And also for now, switching or doing like a vertical scaling, changing from a V1 tier to a V2 tier will not be possible until.
Fernando, we lost your voice again.
Oh, I'm sorry. I think, can you hear me now?
Yes.
Yeah, I'm sorry. Some issue with my headset. Yeah, and just finally, do not confuse these V2 tiers, what we call the STV2 compute platform. They're completely different things. So hopefully you can take care, you can use these new tiers, especially the standard V2, and we're looking for your feedback. Yeah.
Perfect. Thank you, Fernando. If you have any questions about pricing tiers V2, please post them in the chat, and then we'll either answer in the chat or at the end if we have time in person. Moving on, the next feature that we are going to talk about is Defender for APIs. Defender for APIs, a new service in Azure. It's part of Microsoft Defender for Cloud. It's an advanced API security solution that's tailored to providing API security capabilities, protection, and features. It allows you to better prevent, detect, and respond to API security threats in your API management services, and the core capabilities fall into 3 main categories. The first one is the classification and understanding the security posture of your APIs and your API management services. And that includes a unified security overview of all your APIs across all your API management services and subscriptions from the security standpoint. It also includes a detection of endpoints that don't have authentication in place, that are inactive, and therefore just increase the potential surface attack, and also endpoints that are externally exposed, so potentially more vulnerable or with higher risk to your organization. It also includes sensitive data classifications, so things like social security numbers. You will be able to identify the endpoints that transfer those sensitive details. The second category is around hardening API configurations and prioritizing risk remediation. So once you discover where the problems lie, we can help you prioritize remediation of those problems to make sure that you wisely allocate your investments and resources. And lastly, probably the most exciting part of Defender for APIs is the ability to monitor and protect APIs against attacks in runtime. And that's based on machine learning models that model several top attack vectors, such as broken object level authorization, that work on your endpoints and adapt to your traffic and are able to detect attacks that are happening on your APIs. And then it can also integrate with other security solutions like Microsoft Sentinel for alerts and notifications. And I'll not be diving into this site too deep, but you can refer to it in the recording if you're interested. Basically, the point is that API security is a layered defense. API management provides a lot of capabilities natively that help you better secure APIs and your endpoints. And there are also other complementary services in Azure that also increase the security of your APIs, such as virtual networks, firewall, DDoS protection, and there is also Microsoft Defender for APIs. So if you want the best-in-class security for your APIs, you should consider adopting all of these services to build that security in place. And we have a short demo, so I'll ask Wagner to play the recording. In this short demonstration, we'll take a look at the basic capabilities of Defender for APIs. In this example, I have a user management API in my API management service with two operations for getting users information. I can make a bunch of API calls using Postman to that API, and the API returns a basic data contract with users' information, such as a credit card number, credit card code, zip code, and social security number. Note that I'm making calls to an HTTP endpoint, not HTTPS, so not the encrypted protocol, and I'm not using any authentication method, so this API is accessible to everyone on the internet. Back in the Azure portal, I can navigate to the Defender for Cloud Blade to explore the recommendations for my API management service. Defender presents several recommendations, such as, for example, storing secrets, not in the name and the values of API management, but in Azure Key Vault. Among those recommendations are also two high-severity recommendations. One is that I need to secure API endpoints in my Azure API management with authentication. So just what we demonstrated, that I was able to call the API without any credentials, and that my API should be exposed using only encrypted protocols, such as HTTPS and not pure HTTP. So Defender was able to deduct from the traffic that I have some severe issues when it comes to security of my APIs. I can explore those recommendations in detail in the Defender for Cloud experience and see to how many resources and to which resources they apply to. I can also take a look at the unified inventory of all of my API endpoints from the security standpoint across all the subscriptions onboarded to Defender for Cloud with the Defender for APIs plan. In this case, I have only one subscription filtered, and it has only one API management service with 3 APIs. But if I had 20 API management services, I would see many more APIs. I can also take a look at more details about the endpoints that my API management services contain. In this example, we're calling the user management API, which is an active API because it just received traffic, but it has some endpoints that are unauthenticated and that expose external traffic and that they expose sensitive data. So to investigate further, I can click on those on that API and see that the endpoint that we just called is classified to expose social security numbers and does not require authentication. Lastly, I can use Defender for APIs exploration capabilities to filter endpoints that, for example, are exposed to the internet and expose sensitive data, or endpoints that communicate over unencrypted protocols with unauthenticated API endpoints. So those very basic threats, I can explore them using Defender for APIs queries and search for all of such endpoints across all of my API management services, across all the subscriptions that I have. So very handy feature to ensure the security of your APIs at scale. And first and foremost, we have not demonstrated some of the other API management and Defender for Cloud capabilities, such as the ability to detect anomalies in API traffic and identify attacks that are happening on your APIs. Defender for Cloud creates machine learning models for all of your API endpoints, and then is able to use those machine learning models to detect malicious behaviors, such as users trying to exploit broken authorization mechanisms or exfiltrate data. So all of those capabilities are possible with Defender for APIs, which natively integrates with Azure API Management. Thank you very much. The next exciting feature that we have added to API Management is the policy authoring experience with Microsoft Copilot for Azure. So we are harnessing and leveraging the AI capabilities to help you author, explain, and convert policies in API Management. So for example, you can ask the Copilot to generate a specific policy, like a throttling policy or a much more advanced policy, or suggest a policy to solve a certain business use case that you might not even know what policy it maps to. You can also ask Copilot to explain existing policy that might have been authored by someone else in the organization, and you might not fully understand what it does. And lastly, there is also a use case where you might want to, for example, translate some policies from other API management solutions into Azure API management policies, for example, to unify the behavior of APIs across multiple API gateway solutions. So all of these capabilities are possible. All of these use cases are possible with Microsoft Copilot for Azure for authoring policies. And we also have a short demonstration here. So Wagner, I'll ask you to play another demo.
So here I'm in the Azure portal and in the API policy section of API management in the policy editor. And let's imagine I'm a new user and I don't really know what the policies are. I can click this Copilot button and I can ask Copilot to tell me what Azure API management policies are. And Copilot tells me that policies are a collection of statements that are executed on request or response of an API. Now I have this simple API imported to Azure API Management. There are two things I want to configure for this API. First, I want to remove ASP.NET version header from the response. And the second thing is I want to implement rate limiting for this API. Let's use Copilot for that. First, I will ask Copilot to generate a policy with a rate limit of 5 requests per minute. I can copy this policy snippet into my configuration file. Next, let's ask Copilot to generate a policy to remove an ASP.NET version header from the response. Now let's copy this policy snippet into my configuration, save the API, and see how it works. Now when I do a test request one more time, you can see that I don't have ASP.NET version header anymore. Let's send a couple of more requests to see if we have the rate limiting in place. Great, we have all policies we need, and those policies were generated using Microsoft Copilot for Azure. Now, let's imagine a different scenario. I'm someone who is already familiar with Azure API Management, but I have this API which was handed over to me, and I want to understand what's configured in the policy for this API. And while I understand the validate JLBT section, I don't really know what this validate GraphQL request does, so let's ask Copilot to explain it to me. And as you can see, it not only explains what the validate GraphQL request policy does in general, but also provides description for a specific example that we have here. So it shows that we have a maximum size of 100 kilobytes configured for any incoming GraphQL request. We have a maximum query depth configured, and so on. It also says that we have this authorization section, which is used for request authorization, And the first rule that we have in that section is used to reject any request coming to /double_**. But the thing is that it also describes it with the GraphQL context in mind, saying that this is something which is typically used to block access to GraphQL introspection queries. And that is extremely useful to me because I'm not that familiar with GraphQL, but now I understand that this is an important configuration from a security standpoint. And the second authorization rule, which is fairly complex expression, is also explained pretty well. It says that this rule checks if the request is trying to access a specific path, and if so, checks if there is an admin claim in the JWT token in the context variable. And this saves me a lot of time digging through documentation on how to combine validate JWT and validate GraphQL request policies. Now let's imagine a third scenario. I'm currently migrating from another solution, and I have this Apigee configuration which I want to convert into API management policy. This configuration adds an additional header to the response of my API. So let's see if Copilot can convert this for me. Okay, looks good. Let me copy this into my configuration, save my policy document, and test the API. And we should be able to see a new service header which says hello from API management. Microsoft Copilot for Azure not only speeds up the ramping up process for those who are new to API management, but also boosts productivity for those who work with API management on a day-to-day basis, and also helps those who are migrating from another solution.
Perfect, thank you, Wagner. So extremely exciting feature. It can really enhance your productivity as a developer, as well as simplify the management and maintenance of your API management platform. Next, I want to talk a little bit about the gRPC APIs. So we've added support for gRPC APIs in self-hosted gateways, and it's currently in preview. What it means that it's a full gRPC support for client streaming, server streaming, and bidirectional streaming calls as well. It of course supports protobuf, and you can basically bring your gRPC APIs into under management and under governance in your API management platform, alongside other APIs such as GraphQL, REST, as well as SOAP. It also means that you can use policies, just like on any other API, to transform the traffic, protect your APIs, secure your APIs, etc. Same with consumption. It means that you can publish your gRPC APIs inside the organization or outside the organization for consumption by developers. So because you're supporting self-hosted gateways, it means that you have a full flexibility to deploy those APIs wherever you want to deploy them. You can deploy them in the Azure cloud, for example, with Azure Kubernetes Service, or you can deploy them in other clouds or on premises in your own Kubernetes clusters. So extremely powerful features for those of you who are interested in cloud-native APIs and gRPC APIs. And slightly related, we also added support for OData APIs, also currently in preview back in the summer. So first and foremost, it's a similar use case where you want to bring another API type under management and governance in your API management platform, alongside now gRPC, REST, SOAP, and GraphQL APIs. And that also includes OData APIs for SAP solutions. So there are a few other improvements coming soon to support for OData APIs, such as Credential Manager for SAP to easier manage authentication authorization for SAP APIs, one-click import to easy onboard OData APIs from SAP instances, deploy to Azure Center for SAP solutions, and easy creation of OData connectors in Power Automate for consumption of these APIs by Power Apps and Logic Apps. So this is especially interesting for SAP workloads or some other OData workloads. And with that, I would like to hand it over to Julia. And Julia, I think we do have enough time for the demo, so you're welcome to demonstrate it.
Cool. Thank you, Mike. Thanks so much for having me. I think we will be switching back to the slides. Yeah, perfect. So as Mike has mentioned, I will be talking about Credential Manager today. Credential Manager is a new feature in Azure API Management, formerly known as authorizations. And in addition to the rebranding, we also worked on some really exciting new capabilities within Credential Manager, which I will be talking and also showing you today. So super excited for that. Before we jump into the demo, let's talk a little bit about what Credential Manager really is. So Credential Manager is a central repository within your API management instance. You can use it for managing, storing, and controlling access to your API access tokens. And with Credential Manager, you can greatly simplify the process of authentication and authorization. And in particular, with Credential Manager, we will help you with your API access token from the acquisition to caching to refreshment and to the storage of these API tokens. And all of this without having to write a single line of code. So how can you use it, and what are some of the scenarios we see with Credential Manager? We usually talk about two main scenarios. One is an unattended scenario, and the other one is an attended scenario. So what do we mean, or what does we mean with those scenarios? So let's take a look at the unattended scenario. As a first step, we have to do some configuration on the API management portal side. An API manager, for example, configures a new credential provider. After this, a pre-configured connection will get created with an access policy assigned to API management managed identity. And then during runtime, this could then be used, for example, for an Azure function. For example, the Azure function will call our API endpoint and API management. And via our get authorization context policy, we will get the API access token for you from the pre-configured connection, which we configured previously. And then we will attach the token to our API call and get the information we need. I also mentioned the other scenario. The other scenario is our attended scenario. What does the attended scenario look like? So again, some configurations are needed. Again, an API manager configures a credential provider in API management. But this time, only the provider will be configured and not the connection. Because the connection actually gets created when, for example, a user logs into a static web app, because this will then trigger a process of creating a new connection for this user. And then during runtime, a user again triggers our API endpoint, for example, by clicking a button within our static web app. And this will then call our API endpoint in Azure API Management, again, to get our API access token and to attach it to our API call and then retrieve the data we need, but this time based on the user context. So we will get user dedicated data here in this use case scenario. Because we have time for a short little demo, let me show you what this experience looks like in API management. So I'm currently in my API management service instance. Credential Manager can be found on the right here under Credential Manager. Right now, as you can see, I've already went ahead and configured 3 credential providers. You can easily create a new one, and configuring a new credential provider consists of these 2 steps that we talked about. One is the configuration of the credential manager, of the credential provider, and the other one is setting up the connection, which is optional based on whatever scenario fits your use case. So for configuring the credential provider, as long as it's OAuth 2, you're good to go. You're ready to set up your credential provider. We do have a long list of identity providers we currently support, so feel free to pick and choose whatever fits your scenario. So I already went ahead and configured one credential provider here. I'm going to showcase the GitHub unattended scenario here. So how can I see what are some of the connections that I already pre-configured? Because again, for the unattended scenario, you need a pre-configured connection. Here right now, you can see I already created a connection for the user Julia. You can see the status is also it's connected. So this means I have the access token information ready. And whenever I need it, whenever I'm calling my API endpoint, these information can be retrieved. So we talked about the policy. What does this look like? So if I go into my APIs here, and if I click and check out my policy setting, I can see that I'm using my get authorization context policy. I will name and configure what is the credential provider I will be calling, and I will also configure which connection I want to create here. For the unintended scenario, this will of course be dynamic depending on what we are doing, which connection we need. This will look a little bit different, but just to give you an example of what the policy looks like for an unattended scenario here. And last but not least, let me test it. And so we can see that it works. For this, I will hit the test button, send, and perfect, I'm getting 200. This means my access token has been successfully applied to, and I'm ready to get the information I need. I will be handing it back over to you, Mike. We have some links that we can also share with you in case you're interested. Always feel free to reach out to us. And now back to you, Mike.
Thanks, Julia. Could we switch the screen, please? So here are some resources where you can find more information about Credential Manager. Again, those will be available also in the recording, so feel free to take a picture or just watch the recording if you're interested in those things. So very handy feature for really simplifying implementation maintenance of connections to first-party and third-party backend services, and also making sure that those connections are secure. So not only productivity, but also security enhancements. And I want to spend the last 3 minutes, thank you, Julia, talking about API management with OpenAI and why to use API management with OpenAI and some tips and tricks. So again, it's about bringing those OpenAI APIs into API management for enhanced governance, discovery, consumption, right? So again, bring more APIs in your organization for that governance and to make them consumable by developers, either within your organization, which is usually the use case, or outside your organization. And by bringing those APIs to the API management, you can also add security measures to better protect those OpenAI backends and also better protect those endpoints. And that can include improved authentication authorization mechanisms, especially using the developer identity. That can include the rate limiting of API calls to make sure that those OpenAI backends are not bombarded with requests. And that can also include, for example, threat detection with Defender for APIs for much more advanced protection than just rate limiting, right? So API Manager can provide a very powerful layer of security on top of OpenAI backends. It can also provide a layer of observability on top of OpenAI backends. So you can log API requests and perform analysis of token consumption across teams in your organization, or even create event-based alerts, for example, when there's an excessive token consumption. And lastly, you can also load balance APIs across multiple OpenAI instances to distribute the load evenly. And on the right-hand side, there is a simple and sample architecture of using OpenAI with Azure API management. In this use case, we are using Key Vault to securely store the key that communicates for communication between API management and OpenAI, or you can also use managed identity. We are also using Private Link to secure OpenAI from direct communication from client applications, so that all the client application calls need to go through Azure API management. So this is a lot of reasons why it's a good idea to use API management with OpenAI. But we also have many more new features coming to even enhance the scenario further and provide more benefits in the early 2024. So if that's something that you're interested in, keep your eye out, and we hope to announce some new capabilities in the first half of 2024 even better protect and let you manage and productize OpenAI APIs. So with this, I wanted to thank everyone for joining this part of the session and to listen about API management. There's 3 links here that you might be interested in. The first one points to offshore product announcements. The second one points to release notes for our service deployments. And the third one is the blog where we post articles about upcoming features.
Thanks, Mike. I'll add Julia to the stage as well, and Fernando, because I think there is like a couple of questions, and just to guarantee that any one of you that wants to answer can answer that. So I know Fernando was quite active on the. It was quite active on the chat, but there is some questions here that I think that people would wanted to hear more, and because we have those 5 minutes, let's go through that. I'll start with the one that was not being answered yet, and I think that's for you, Julia. Is Sebastian is asking, just for understanding, it is possible to implement the principal propagation of the SAP with credentials, with the credential manager?
Yeah, awesome. Happy to take that one. So we currently don't support SAP as an identity provider. In case you want to manually set it up using OAuth 2, that's one way to do it. And we are looking for this more further down the line to add SAP as an identity provider for Credential Manager.
Cool. I think that one is for Fernando, but correct me if I'm wrong. Is a question from Ruben. Maybe I missed it, but what is the advantage between Premium V2 versus Premium? I think you answered that on the chat, but just for everyone that pick up, because it's quite something that probably a lot of people is interested. You were on mute.
Can you hear me now? Yeah, it seems like my headset mutes every certain minute, so let me know when you lose me. Yeah, so the main advantage is that Premium V2 will have enhanced VNet injection. Traditionally, with Premium V1, when you want to deploy inside a VNet, you need to open network security ports and rules to our own dependencies of the services, Azure Storage, Azure SQL, logs, monitoring. And if the customers do not open this NSG ports, basically the service will not work correctly, right? So we give customers this option, but if they don't configure it correctly, the service works badly. So Premium V2 will fix all of that. All the internal traffic will run in a separate network interface. So VNet injection will be completely easier. That's why we call it enhanced VNet injection. I would say that's the main advantage. We have more things coming, but we will announce them as we get closer to a public preview of Premium V2.
I think it's also worth pointing out the improvements in faster scaling and provisioning times. So that's
yes,
very, very important as well.
Yes, of course. Deployment times will be lower, configuration times will be lower, also auto-scaling, scaling out horizontally, all those times. Basically, those are the benefits of the V2 tiers. Deploying API management V1 takes up to 45 minutes, 1 hour sometimes. Now we can take 5 to 10 minutes. So yeah, those are also big improvements. Yeah.
Awesome. Next one is I think is in relation to API management. What is the context that the Copilot have? I think the question here is like what he can access, what he cannot from the API management fabric when he's asking the questions.
Right, so Copilot works on the policy at the moment. So all the use cases are limited to the policies in your API management service, and it's also trained, of course, on the documentation for policies. So it's able to suggest to you some, help or assistance, provide assistance in terms of policies, but not in terms of any other capability at the moment. So the context is, within the policies, public information as well as information that's specific to your service, where you can. It's more about contextual. It doesn't really know what's in your service. It's more about you being able to select, for example, like we showed in demonstration, a specific policy, and then basically pass that policy to Copilot for explanation.
Okay. And is on the policy that is open, or you explicitly pass that as part of the
Yeah,
prompt?
so this is just a user interface gesture, right? So by itself, I don't know. We don't have engineers who worked on the feature, but I don't expect it to be aware of like all the policies that you have in your API management service.
Cool. Thanks, man. And then still related to Copilot is a bit of a question and a comment, right? Currently, there is no information about the pricing for that.
Right. So I don't think we are the right team to talk about that. We are basically part of Microsoft Copilot for Azure. So in terms of availability, if you want to use our own Copilot, you have to get access to Microsoft Copilot for Azure, as well as the pricing will probably be the same for both solutions. We are just a component of Microsoft Copilot for Azure.
Cool. Thank you. I think those are the questions, although in the meantime, I have like 10 live questions. Just let me see if there is anything else, because we are at the time. So I think there's other comments and questions about that on the chat. There is another 10 of those. If you go through that, we're going to derail the Julia's session. So the Mike and Fernando, if you can take a look at that one, then I'll pass it straight to Alex to introduce.
Yeah, we'll take a look at the questions in the chat, and thank you for joining our session.
Yeah.
Thank you.
Thank you, everyone.
Thanks,
Thank
guys.
you, Mike. Thank you, Fernando. Thank you, Wagner, for bringing me back in. Julia, welcome. I'm glad to still have you. And yeah, go ahead and take us right into your session.
Awesome.
Azure
Thanks,
API Center.
Alex.
Yeah.
Very convenient if you're overlapping with the other session. Hi, everyone. Again, my name is Julia. I'm a product manager in the Azure API Management organization here at Microsoft. Today, I will be talking about Azure API Center. So Azure API Center is a brand new Azure service. We are currently in public preview. And something we are seeing today with a lot of customers, or what is this product all about, is APIs are really expanding at a remarkable speed. More and more customers adopting to an API-first strategies. They are using APIs for connecting different systems, for building different systems. So we really see a big growth here for APIs. But with a lot of growth, there also comes a lot of challenges. So one of these challenges, for example, API sprawl. But what does it mean, and what kind of challenges are these? So APIs are being deployed across different services, across different platforms, across different gateways, right? And with this deployment everywhere, this can lead to a lack of visibility for all kinds of different API stakeholders, like API developers, for example, or API managers, or API program managers. And with this lack of visibility, it becomes really hard to keep track of all of your organizational APIs out there, and their deployment location, their configurations, their API specifications. And this is exactly where Azure API Center comes in, and one of the challenges we really want to tackle with Azure API Center. So as I mentioned, Azure API Center, it's a brand new Azure service. It's currently in public preview. And what is Azure API Management? So we really want to narrow down to create your organizational API hub for all of your APIs out there. And whenever we look at Azure API Center, what are the 3 themes we currently see within Azure API Center? One is creating and maintaining an organizational inventory. So we want you to be able to create this inventory of all of your organizational APIs out there, to make it reusable, to make it transparent to all of these API stakeholders out there, and all of this in one single place. The second one is API governance. One step of API governance is having this one repository, this one place where all of your APIs are being tracked. The other addition to it is maybe you want to store additional information to your APIs. And this is where we are introducing the concept of custom metadata. And last but not least, API discovery is also a huge pain point we want to tackle with API Center. API Center or API discovery can be done via the Azure portal experience, but also via API Center portal experience. So you don't have to grant access everyone to your API Azure portal experience. You can use API Center portal to provide this kind of discovery experience for all of different API stakeholders out there. For example, API developers, API managers, for example. Talking about API developers, we also want to meet developers where they are at, especially API developers. And that's why we also, for API discovery purposes, are introducing a Visual Studio Code extension for API Center. But yeah, let me show you what all of this means in action. I have a demo prepared to show you what Azure API Center looks like in Azure, but also talk a little bit about the Visual Studio Code extension here. So I'm currently in Azure. I currently have set up an API Center instance here. So what does the current experience look like? We talked about APIs and having this one single place where you can store all of your APIs. As you can see, I already registered a bunch of APIs here. And we have multiple ways or different ways to register APIs. One is a manual way via the Azure portal experience. Another one is a more automated way because we love automation. And especially from an enterprise perspective, you want to make this process as easy as possible. Before I show you how to import APIs, let's touch on the topic of custom metadata, right? We talked about it whenever we talk about API governance. So again, custom metadata is a way to store additional information on top of your APIs. Currently, I have 4 example custom metadatas set up here. One is API approver, cost center, compliance status, and test. There are different data types coming with your custom metadata, so it's super flexible depending on what is some of the information you want to store on top of your APIs. All right, let's talk about how can I bring or register new APIs into my API Center instance. Let's imagine I'm a .NET developer. I'm currently in Visual Studio Code. I'm building out a very simple weather API with one very basic controller here. I have a get operation. So I want to get date, temperature, and summary of my weather data. We all know the good old weather API. So again, very simple weather API. One asset I'm creating based on my controller, based on my definition, is an OpenAPI spec. And now this is the only thing we need for registering a new API in API Center. I talked about automation. I talked about how much we want to make it as easy as possible. So for this, I'm using our Azure CLI. And with just one single line of command, you can easily generate a new API within your Azure portal. Let me hit the enter button here. And what will happen here under the hood is, first of all, we are referencing our resource group. We are referencing our API Center portal and also an API location. This API location can be within a file, or it can be pointing to a URL to make it as easy as possible, again, for you to take your API, to take your spec and bringing it into your API Center. So what happens under the hood? We are creating a new API in API Center. We are detecting the API version. We are detecting the API definition and are uploading the API specification here. So let's check on the API Center portal if this has been refreshed here. For this, of course, I have to switch to my API tab here. And perfect. You can see my new API has been registered. And again, it comes with the version. It comes with the OpenAPI spec. We talked about custom metadata. So I defined 4 custom metadata properties, and these I want to add within my API Center portal. So I can easily just go in here and provide some of the functionalities, marketing, just some information. And I also want to store the compliance status, which is currently still open because nobody of my API managers has taken a look at this yet. And then just a test property as well. And let me hit the save button. Perfect. So additional information is being stored on top of your APIs. All right, so we talked about registering API, we talked about custom metadata. What about the API discovery experience? For this, we are introducing the API Center portal, which comes with every API Center instance you're creating an API Center. And that's what the current experience looks like. I'm not signed in yet, so let me show you what the process here looks like. I created a user here. I, of course, have to provide my credentials. All right, what's happening? Currently, I'm not authorized to access this portal because, of course, access should be controlled. So this is where we can switch back, and via access control, we added a role so that you are in charge of who is available to see all of these APIs out there. So let me add a new role here, or a new user to my API Center Data API reader. I can go in here, search for my members who I want to grant access to my API Center portal, and hit the review and assign button. This means I'm now adding a role, and perfect. This has been done for me. Let's check on what the experience now looks like. Let me close on it. Let me sign in again, and perfect. Now, because I have access, I'm able to see all of my organizational APIs out there. So what can you do within the API Center portal? You can search for APIs. You can filter for certain APIs. There are different ways to displace APIs as well, depending on what you prefer, what you want to do. But you can also share your APIs, either via email or by copying a link and maybe sending it or referring this to another developer, to another API stakeholder here. If I click in more detail, and let's search for our perfect weather API that I just recently added. Some things you can do, you can of course download the API definition, depending on which version you want to check out, which definition format you want to get from this API. This is what I meant at the beginning when we are detecting your API version as well, depending on what you have stored within your API definition. And we will retrieve this information and put it into API Center here as well. All right, so this is one piece of the API discovery journey. The other one is our Visual Studio Code extension. We really want to create this product for our API developers out there. So this is where our extension comes in. Let me open up my API Center here so you can see what the experience looks like. This is our current API Center extension. You can see, I can see the API Center instance itself, and I can see all of the APIs that come with my API Center instance here. We are working together with our Copilot team because we wanted to create a really nice developer experience. What if you don't necessarily know what is the API I want to search for? What are some of the APIs I can find? So this is where you can use Copilot to help you with your developer experience here. Currently, we support two different functionalities. One is, for example, list. And as soon as you hit this one, Copilot will retrieve you a list of all of the APIs out there that you can find in API Center. It will provide you the title, the description, and the operations coming with it. And this in a very quick and easy way for you to see, oh, what are all of the APIs out there? What are some of the descriptions? What are some of the operations? If you already know what kind of API you're looking for, you can use our /find. And right now, let's think I know I want to find an API, something with cats. So let's hit my enter button here. Let's see what Copilot does for me. Perfect. It found me one API that matches my search criteria. Currently, we have a cat fact API within our Azure API Center instance. And these are the operations coming with it. So I'm getting a quick overview of, first of all, what this API is, a little bit of a description, and all of the operations that come with it as well. Let's check if this is actually accurate. So I can go back to my extension. I already have my cat facts API open, and you can see in our definition folder, here's the open API spec that I'm looking for. Within our extension, we support 3 functionalities. One is opening API documentation. So let's do this. And this is where a Swagger preview file will be auto-generated for you in your IDE. So you don't have to leave it. And you can either test it, you can find out all about these operations. So let's check on Copilot. Currently, I see I have 3 operations, 3 get operations. If I check what Copilot told me, perfect. Yes, I'm getting the same information here. It's just a different way of discovering these APIs, to getting information about all of your APIs out there in your API center. All right, so what else can I do? Let's go back to my weather API and let's see what I can do here as well. Or maybe let's take a different API. This seems like there has been some uploading issues. But again, so I'm searching for my OpenAPI spec here. Another functionality that I want to do is generate an HTTP file, so I can use a different extension for me to actually test and test and get some more exposure to this API as well. The other way always is opening up the API definition. Again, I can test within my Visual Studio extension here as well. So let's see if this works. Perfect, I'm getting a 200 and my body responds here as well. Last but not least, the last operation we are supporting is generating an API client for you. So as a developer, and let's pick the example of I'm building a web application, and within my web application, I want to use some of my APIs. How do I do this? Ideally, I want to have a client. So this is where Azure API Center comes in. You can auto-generate an API client based on your OpenAPI spec or based on the APIs you have within your API Center instance. And this is as easy as selecting which of the endpoints you want to expose via the client. And you can pick and choose if you want to have this within your client, yes or no, and then just easily hitting on the play button here. And this will auto-generate your API client so you can reference it in any other projects like your web application that you're building for a different use case. All right, let me quickly summarize what we have seen today. So we have seen create and maintain an organizational inventory. We went into API Center, we saw what the experience looks like in Azure. We talked about the APIs you can see there. We talked about access control for API discovery. So these are some of the things you can do with your inventory for your organizational APIs. Then we also talked about governance. We talked about custom metadata. We saw how easy it is to add a new API into API Center and to add additional information that you previously defined as custom metadata. And finally, we talked about API discovery in 2 ways. One, via the Azure API Center portal experience, and then the other experience via our Visual Studio Code extension from a definitely more developer perspective, but just for you to see what are all of these APIs out there. You don't want to leave your IDE. We want to meet developers where they are at. So yeah, to wrap this up, as I mentioned, we are still in public preview. GA is currently planned for March 2024. What are some of the things we are working on? For inventory, we want to support bulk import, especially APIs from API management. We love automation. We talked about this. So we want to support functionalities or support for GitHub Actions and DevOps pipelines as well. From a governance perspective, we are currently working on an integration with Logic Apps. So API managers or API program managers can build custom workflows based on certain trigger events happening in your API Center instance. And then last but not least, for governance, API guidelines or API design guidelines is something that becomes really important, especially if you're bringing a bunch of API specifications into your API Center. So we are currently working on what does it mean from an API Center perspective to design or create these API guidelines, and ideally to also link these API specifications and get some kind of recommendations, what you have to do from the perspective of your APIs, what you have to change, and to make them really compliant for your organization here as well. And then again, from an API discovery standpoint, we talked about the Visual Studio Code extension. We will definitely add more features, more functionalities here as well. And then from a portal perspective, we saw the API Center portal experience here. To make it more customizable, we are currently working with Backstage to provide a plugin. So customers out there can create an API Center portal that really fits their needs. And depending on their recommendations on their needs, they can really create their own custom API Center portal experience here using the Backstage plugin. So yeah, thank you so much for taking the time. Feel free to reach out to us if you have either any feedback for us, any problems. Always happy to chat and hear what your current experience is with Azure API Center. And now back to the studio. Thank you.
So we do have a few questions for you, Julia, and we do have a few minutes as well if you're open for it.
Yeah.
And Pierce has been answering some of these, so some of these might end up being duplicates. But let's start with Ritu. He talks about, from where do we access this portal? It's not easy to get this on the API Center resource itself. Any thoughts about that?
Yeah, I love the question. So we are currently in a new release train. So the API Center portal will be available in our next release publish date, which is mid-December. So from then on, we have an experience within Azure Portal where users can first configure their API Center portal experience. It comes with a few of configuration things you have to set up before you're able to access it. And then we will have a link, a button for you to easily access this API Center portal based on your API Center and based on all the APIs you brought in.
Cool. Sounds simple enough. So here's another one. Do you see API Center portal as a competitor for the API developer portal in the future, or should they coexist?
Good question. We get these a lot, especially with what do customers do who have API management and API Center together. So API Center, we really see of a curated list of all of these APIs out there. A lot of our customers have multiple API management instances. So API Center comes in when you have multiple API management instances, for example, and you want to have this one list where all of your APIs are there. For example, some customers have one API management instance for only their region in Europe, another API management instance for only the US. If you want to have a curated list, then this is where API Center comes in, where you can bring in all of these APIs. And then it depends on the use case. If you want to have a portal for all of these APIs, then we would recommend, of course, using the Azure API Center portal. If you still need the developer portal coming with API management for certain regions, for certain functionalities, then we would refer to API management and developer portal here. So it depends on your use case. Feel free always to reach out if there are any more questions on this, but this is what I would give as an answer.
And then there was Sebastian had made an observation. So just looking, I guess, for some validation perhaps, but like, is there an element here of external versus internal consumers when trying to make that decision?
I love it. So as of right now, we are focusing on internal consumers developers. As a next step, we already have on our pipeline, on our roadmap, external as well. This will most likely happen after GA, but it's definitely something, some functionalities a lot of customers are bringing already to us. But again, if you have any kind of feedback, always happy to hear this. It's definitely on the roadmap here.
Okay, and one last one, and Pierce did respond here, but just we'll just show it for the recording so people can see it. And that was the API client outputs and looking for different languages. And Pierce had gave a pretty comprehensive list here, so I don't know if there's anything to add or not to this one.
Yeah, that's perfect. That's the list we have. I feel bad that I didn't show the entire process for what it looks like within Visual Studio. But yeah, these are all of the languages we support. Whatever you want your client to look like, whatever support you need, these are some of the examples we support.
Awesome. So I think that's it for questions. So thanks, Julia, for joining us here. And I believe we have our next session starting in about 10 minutes. So I think we can take a short break, and Wagner's changing his producer hat for his presenter hat. So we look forward to seeing Wagner and Parth talk about the improvements to the local developer experience for Azure Logic Apps.
Awesome. Thanks, Kent.
Thanks all. Thanks, Julia.
Thanks, Kent. Yeah, and it's good that we can have 10 minutes break because my machine is super slow. I'll probably have to jump out and jump back in. I'll put the be right back, and we're back in at at 10 past, everyone.
Sounds good. Thank you.
Thanks. I just needed to find it, and it's slow. Hello.
Hey, Wagner.
I think we are almost there. I just realized that we didn't talk about how things going and what people are thinking about this session so far, because I've been learning a lot on the other products that we don't have time to play that much. So if you have any feedback on how things are going, please add that to the chat and we can show. By the way, probably at time. So
yeah, 2:10 p.m. Pacific. So
let's add Parth to the stage. Let's remove this banner. So we are officially back.
Can you guys
I
hear me?
guess I can get out of your way as well here.
Yes, cool. So the whole gang is here.
Alrighty.
Let's start.
Yeah, next up we've got our own Wagner and Parth talking a bit about Logic Apps Standard and some news. Take it away,
Cool.
guys.
Thank you.
Thank you, Alex. Thank you, Wagner. Let me just, I think the screen is visible. Let me just start with the agenda first. So we have three things. First is to, showcase you guys new capabilities we've gotten on VS Code with Logic Apps Standard. This will especially help the pro developer use case for us. And the second is for automating deployment scripts, tooling generation. So today you have to manage all of this, and especially when you are trying to deploy in production and other environments, it's quite difficult to wrap up your entire application and also make changes in real time, right? So we have something in that too, and we'll leave some time for Q&A, but we'll have some demos for both of them. So without further,
just before we start, because I think people are so used to our faces that we don't even introduce ourselves anymore. But I'm Wagner Silveira. I'm Senior Product Manager at Logic Apps team. And let you introduce yourself, Parth.
Yeah, I'm Parth. I'm also a product manager with Logic Apps team, and been here for a couple of years now. So enjoying, making Logic Apps a better place for developers. And I think then we can jump into. We should have jumped into the agenda.
Let's go to the good things.
Yes, I think let's take a look at the context, right? I think when we were starting to develop Logic Apps, we focused on Portal, and after that, we started developing for the standard SKU, especially that was helpful for developers to start developing on VS Code on, right? For that, so now in that process, we had a lot of roadblocks, right? When you're trying to onboard to VS Code, you have to install a lot of dependencies. And to do so right now, you may have to go to documentation, find all of those particular dependencies, the right versions, and install it, right? And now this is not only quite arduous, in terms of how much effort it takes, time consuming and whatnot, but also kind of messes up with your own environment that is, fine-tuned for other applications, right? Apart from Logic Apps that you may be using, right? So in that case, like, we wanted to help, first of all, to make this time shorter, that you can, get to designer and start focusing on business logic and really get that low code, pro code, experience in VS Code. Because we want to give that extensibility, not just in Portal, but also VS Code. And moving further, we also want that, crisscross extensibility. So if you want to migrate anywhere, you can do so. That's another tangent. Especially for the onboarding, we are bringing you a few different kinds of features. The first, the main two ones were to automate the prerequisite installation through binaries. This will be only particular to Logic Apps, right? And we'll look at it in the later slide. And then also to speed up the application start. So you have to run the design time, you have to run the Azure, right? You got to start all of these things, right? And to do so, again, manual work required to write some functions, commands, and things like that too. Or maybe it takes a lot of time when you're trying to open the designer, right? Especially through that workflow JSON file. So first of all, when we look at the prerequisite installation, as I mentioned, there were a lot of dependencies. These will all be available for you to automatically install in the new version that has come out for Logic Apps. So please update to that if you haven't already. And in that, we have this automatically checking of the dependencies if you already have them. So we won't touch it. But if you don't, like, it will automatically validate and create separate folder, right? Based on a portal binary package that will contain all the dependencies, right? And this location will be a predefined one, which can be configurable in settings, obviously. But the main idea here is not only it takes less time for you to start running the environment, but also like it decouples the logic app requirements from your other system variables, right? And other system softwares that you may be using, right? So this is currently in public preview, but we have exciting news for it ahead. But for today, and especially going to application start, you have to download all the bundles during extension start. So this is what especially the binary installation will be for. And it also install Azure Write in this case. And to even speed up your application start, we are automatically starting design time on Azure Write, right? And this again can be configurable in settings. It will be a notification that you'll receive. Again, you've seen the demo. And this is all again for the Azure location as well, configurable. And now, as I was saying, the big news, this is available in GA today. It's not just public preview, right?
And just a note on that one, because of the and that is my bad. The starting design time, the runtime for design when project start and starting Azure Write is already available. The download bundles is a byproduct of starting the design time, right? So it's right now is on project start, but the changes that you're doing when you bring in the full onboarding on GA is also download that as soon as you started the extension. So it happens behind the scenes, and then you don't have to wait extra time if if there is a new bundle and we needed to work with a project.
Absolutely, Wagner, and I think you are creating the perfect segue for I think as we want to start showing them the capability. So please do check out the link as well. We have a blog post on it, and without any further ado, I'll pass it on to Wagner for this.
So let me share my screen, and then jump here. So what I'm going to do here is I'm going to show you the experience that would have if you install the extension first time, right? So when you open Visual Studio after installing the extension for the first time, what you're going to see when the extension start is a series of questions for you. So extensions just started, and this is what is going to happen. We ask it if you allow the auto runtime dependencies to run when the extension launch. If you say yes, then a series of things are going to start to happen, right? You can see here that is validating the functions runtime, then the notification, the node runtime, and then the .NET SDK. If I open my terminal and show you a couple of things, you're going to see all that information here on the Logic Apps start standard outputs. So it shows what happens. Because I already have those dependencies installed, it didn't install again. It just confirmed that things was there. And you can see that that is actually installed on a portable location. That's what we're calling. So is that under C uses Azure.Logic Apps, right? So if I come here to this location, come on. You're going to see that dependencies folder, and underneath each one of those, you're going to have the actual .NET 6 or the functions core tools or the Node.js, right? And if I remove one of them, let's say I doing this, do that as functions core tools 1. Next time that the extension starts, so when you reload the window, the whole thing is going to happen again because it validates. and it finds the function runtime doesn't exist, then it goes and downloads and installs. Right, so it's doing the whole process for us now. It's like extracting and running the whole thing. When it finishes, then it validates the other ones, and we're going to see that the functions called tools is back here. Okay, so that is going to be doing. That means that when you're having updates on those items, this whole thing is going to happen again. The other thing that I'm going to want to show you very quickly before we go to the next one is if you create a new project, right? And in this case, I'm going to create a new create a workflow, run that even in the current window. So we started the demo folder, and now you're going to see that not only is doing that, but it also started Azure Write for us, and it started the design time for Logic Apps, which means that if I go to my workflow and open the designer, right, just taking see if it's going to take a bit longer. It's taking a lot less time than it would be usually to get that designer in place, right? I'm not going to do connection for Azure, just to show that it's available there. So those are the improvements that we've been doing. Last thing before we go back to Parth is, if you wanted to do any configuration or fine tune on that, if you go to the extension and looking at extension settings, you have all of that at your fingertips. Like, what is the dependency path that I wanted to do? If I don't want it to store it here, I can change that, store in another place. I actually don't want it to use this because I only use the machine for Logic Apps standard. I already have that on the system. You can turn it off, right? We don't recommend, because that is going to make it much easier for you to upgrade and move on to the next steps, right? But you can do it. I don't want it to start Azure Write automatically. I don't want it to start the design time automatically. All of that is on your fingertip, as well as the location on where you wanted to add any one of those items. Okay, so you have all of that ready for you to use and to fine tune as you want. And with that, let's go back and bring Parth back to this. Sorry, I forgot that I was in different place. So just bring that. Oh, yours, Parth.
Yep, let me just go ahead. I think the next one is for automated deployment scripts. Is that, you wanted to take this one, Wagner?
Yeah, I can talk about that one. So if you can go to the next step.
There we go.
Okay, so what we wanted to do with this with this new feature is guarantee that you have separation from concerns from the start, right? So a couple of things that we wanted to do, and that based on feedback for the customers, is the way that we were creating Logic Apps on VS Code, everything was hard-coded to the current instance. And because of that, it would be hard for us to go and move. Like, my connection JSONs is hard-coded to where I created the managed connections. My parameters, if I needed to abstract that, I have to create a different copy manually and do all of that myself, right? And have to do this process of swapping parameters and swapping connections.json, all of that manually during my DevOps process. And the only guidance that we have this process is documentation today. So taking that in consideration, we're doing a couple of things here. One is we're working on connections parameterization from the start. So when you're creating a new managed connection or an API connection or a functions connection, it creates that. We're doing auto generation of those deployment scripts as a gesture. And we're working on some Azure DevOps tasks to make it easier for you to onboard things that you already have. So if you go to the next one, Parth. So as we're saying, for the connection parameterization, we parameterizing connections.json, right? Using a combination of parameters and app settings, like moving things to parameters when they need it, when it needs an object, or to app settings when you just needed a string, right? Or when you needed something that can become a key. So in production, we can connect that to Key Vault. And we're doing that for Azure Managed Connections, to Functions Connections, and API connections, right? And now all of that is happening on the connection creation. So you start the development with the parameterization already in place. Then you create your connections, you're happy with the project, everything is fine. That's where we started to create those deployment scripts. And the deployment scripts that we're creating on this private preview is a set of ARM templates for Azure Managed Connections and for the Logic Apps infrastructure. So if you have Azure Managed Connection on your Logic App, it's going to create that template for you, so you can go and deploy that as part of your process. But on top of that, we're actually using those connections and those parameterizations that we're creating together and give you a set of pipelines, and infrastructure pipelines, the CI and CD pipelines, for you to connect that to Azure DevOps. And finally, we also creating cloud parameter files that we can use to to replace that, and not just that, doing that replacement for you as part of the CI/CD pipeline. So now your local code and your code that you deploy can coexist without clashing over each other, which was a problem that we had before, right? So to show how that works, let me go back to my machine. And in here, I have a private preview of this of this tool, right? So what I'm gonna do is I'm going to be close the folder that we just opened. I'm going to create a new project, and one of the things that we're introducing here is the ability to because we're going to be using more and more workspaces to put all of those different files together. We are creating a new Logic Apps workspace. So putting that on my CDev, AIS Day. And inside that, I'm going to create a workspace. So this is AIS Day IC demo. I now have the ability to say I only wanted Logic App on my workspace because I might not be using custom code, or I can have Logic Apps plus custom code, right? On that one, I'm going to create, just for sake of brevity, I'm going to create one with just Logic App. The Logic App name for this project is going to be AIS Logic App. AIS Day Logic App. Going to create one workflow, and I'm going to call that AIS Day Demo. I'll open that in the current window. So it's going to replace, and like it did before, is going to validate the things. It's going to start the Azure write and get all that project ready for me to run. So if I go to AIS Day Demo and go to workflow.json, open the designer, just going to take a little while to do that. There we go. This time, I'm going to use connectors from Azure and just let it load my list of the subscriptions. I put in that on AIS Logic Apps PM, export demo. Then now I'm going to create my Logic app, right? This is going to be one of those super complex. I have a request. Then after that, I'm just going to add an action for Dataverse. Just waiting for it to load all the managed connections that we have, just because we have too many. There we go. So I'm going to just list rows. I'll use Lydia. I'll use the Contoso environment. What is my... Okay, I'll just use that one. Sorry, I think I used the wrong connection. Just let me move back to Wagner. Select an environment here. What? Going to create a new connection because this is not looking like the right one. Me. There we go. Okay. There we go. So I creating a new connection for myself, new default environment table account, right? So when I save this, there's two things that are going to happen here that we wanted to see. The first one, and when I'm looking at the connections.json, you see that instead of all of that being manually created, we have app settings created for the subscriptions, the location, everything else. We have parameters for the connection runtime and parameters for the authentication. So if I look at my parameters.json, I have all of that in place, right? And then finally, if I have the look at local settings, I have connection key and connection URL put it in the place for me. So now that Logic App should be ready for us to run and everything else. Because of just interest of time, I'm not going to run this Logic Apps just to prove that it works. Because what I really wanted to show you guys is if I click on the Logic App, I have this new option to generate deployment scripts, right? And then when it's doing that, it goes through the process of generate those deployment scripts. And in here, I provide a set of information, right? And I provide a subscription, I provide a resource group, then I provide the name of the Logic app, and this is going to be AIS demo test, actually AIS day demo test, AIS day demo store for the storage account, AIS day demo ASP for the app service plan. And I'm going to create all of that in a new deployment folder that is going to be added to the workspace. And that's what it did, right? So in here, it creates a new deployment folder with the AIS demo day test. And inside that folder, we have ADO pipelines. So we have an infrastructure pipeline that basically gets all those ARM templates and push into a location that it can be executed. We have variables that are associated to that template. What is the environment, where is going to be the resource groups and all those things. All of that based on the information that we provided. And we have an infrastructure pipeline template YAML that calls the Logic App and the Common Data Service 3 deployment, Common Data Service 3 connection that I create. If I had more connections, it would be creating one task for each one of those, right? We also have the CI pipeline that goes and build your Logic App, including replacing your parameters file and publishing that for you to use, and the CD pipeline that gets this and publishes that Logic Apps settings that you might need it to update and deploy the Logic Apps workflow. All of that with accompanying variables, so you can actually plug in your own variables for your ASDO environments. From ARM templates, we created a ARM template for the Logic App with its parameters and ARM template for the Common Data Services connector, right? And this is going to be used by CD pipeline. And finally, we have the parameters for the parameters for the cloud, and you can see that it already took care of the parameters.json, while locally it's using the raw key with the connection key that we provide, right? On the cloud, it's already changed that to manage identity services. So it does a lot of this work for you, right? For sake of time, I'm not going to have time to go and deploy all of that to Azure DevOps and run the end-to-end, but we've been doing work with that, and it's really close to all of that being working seamlessly. So just remember that all of that is private preview right now. And maybe if we go back to the Parth's folder, did you stop your sharing your screen, Parth? There we go. So if you go just back one, where we had the demos, one thing to get there is like we been getting request of interest for the private preview, right? And we're going to be sharing that link for you if you wanted to join the private preview of that feature. And we're planning to launch that around December 4th, so next week. We're doing the last steps on that. With that, I think is we open to questions. Not sure how we're going with time.
So we have a few minutes, so I think we're good.
Cool.
So we've got a couple comments and a question. So the first comment was related to like the dependencies with the, basically figuring out all the dependencies. So there's some positive feedback here. So I think you're on the right path from that perspective. Then there was also another comment, and this was related to the infrastructure as code that you just showed. So big Mickey, this will save half of the development time. So once again, some
Very
positive sentiment there. And then there was a question here. So I think I missed it. Where should we go to generate deployment scripts?
Let me add my thing to stage again and show one more time. If we are on a project for Logic Apps and you right click, you're going to have that gesture called Generate Deployment Scripts. And from there, it goes and starts that process. to create the whole thing again, right? That means that you can like keep on a cycle of working, deploy, generating scripts, working, create, generate scripts, and that is going to be when you push that to source control, it goes there to the project for you. The other thing in here is you see that this AIS Day Logic App and that deployment were folders that you selected as part of this process. So if, for example, if you make some manual changes here, but you wanted to get a fresh copy of this to make comparisons or something like that, you don't need to change your updates. You can actually do this whole process and then just deploy that to a different folder. So it's fully under your control for that.
And I guess for folks interested in joining a private preview, for customers that haven't gone through that before, what can they expect if they are interested in joining that private preview?
So when you join the private preview, we're going to be sending to you a private physics, a private extension that you can install. We're going to give you the instructions on how to access the private bits that are required for that. And usually that is allow you to do either on a different machine or on a VM. That is not going to impact anything that you do on your production, right? So on that one, for example, the changes that we're doing are specific for the project that you're creating. It is not going to impact anything that is other projects that you have, and you have access to that. One thing that we expect as part of the private preview is that you open to provide feedback, because what we wanted with this is, one, validate a couple of hypotheses that we have, and two, make sure that what we're doing is working for you before we go and continue advancing and pushing that to production.
Okay, that sounds great. And one more question just came in as you were talking. Would there be support for referenced connections? It does work now as well, but parameterization becomes manual. Would be good if connections can be selected from other resource groups easily in the designer.
Reference connections in this case would be like connections in other resource groups than the one that we defined. Like with that, we'd allow it to deploy to different resource groups, right? But I think it's still a point that during design, we select a place where those connections are going to live. One thing that you notice there is an improvement here, Ritu, is before you have to manually create the connections, even if the connections already existed in the resource group, right? With this, with some of the improvements that we've been doing lately, when you point into that resource group, it brings like the other connections that already exist, which means that you don't have to recreate new connections all the time. Not sure if fully answer your question, but if not, put some comments on the comment session and I'll come back to that.
All right, and then you'll also add the link to submit a nomination for private preview as well when you have a chance?
Yeah, I'll add that. Mm-hmm.
Awesome. All right, so I think we're pretty much at time. We've got about 2 minutes, but there's no additional questions. So unless there's any final thoughts, we could probably wrap this one up.
Please join the private preview and provide feedback, because we wanted to make sure that this is working well for you as a developer. And I totally relate to the sentiment being on the other side for less than 2 years ago. It's such a relief to get those things easy to install and hopefully faster to go end to end. That's what we're aiming. We just wanted to make sure that we are in the right path.
So much like voting, please provide feedback. Otherwise, you can't complain. Is that what you're saying?
Exactly. we give you the chance.
All right. Well, thanks, Wagner. Thanks, Parth. Some interesting stuff. Some capabilities that I know people will be using a lot in the future. So thank you.
Cool. See you all later.
Oh, Oh, sorry, Alex.
Oh,
Yeah, there we go.
no worries. Alrighty. Well, thank you, Wagner and Parth. So next up, Kent's gonna switch back off from being a host to now being a speaker. Kent, I'll pass that one off to you to give us a little bit of chat about low code, pro code, or why not both?
Okay, let me, I've got two screens going here, so let me just give me one moment, because let's just make sure I
No
share the right
worries.
screen here. All right, okay, so I can't make a mistake. Let me just, okay, so we'll, all right, if you can just give me an act that everything's clear.
Yeah, I think you're good to go.
Sounds good. And then I have, how long for this session, just to make sure I'm, when does this end?
You've got until 3:10.
Okay, thank you.
Yeah.
All right, so let's jump into this. Let me maximize my screen. And I have no idea why it keeps doing that today. All right, so low code, pro code, why not both? So this is the agenda for this session. So we'll talk a little bit about why low code, and then we'll talk about why pro code. And then we definitely want to get into demos. So we're going to spend most of the time in demos. And then there's a nice little surprise here at the end for what's coming. So another little demo on something we're working on that I think you're all going to be interested in. So let's go ahead. Let's dive into it. All right. So why low code? Logic Apps is a low code platform, and there's a reason for that. We do want to democratize who can go ahead and build integration solutions. You know, if we look back at history, we had, BizTalk Server, and it is a very capable integration platform. However, it was not the easiest platform to learn. For you to become productive was generally taking some time. For you to become an expert was even longer. And Logic Apps was born out of the need to simplify building like workflows or integrations. And by making it simpler to use, it allows us to scale. By lowering the barrier of entry, including more people in the app building or the integration building experience. Now, how do we do that? We do that generally through drag and drop visual experiences. And the idea there is that it can, create a more welcoming experience for people to build these solutions, and for, experienced developers or more technical developers, it should accelerate the time it takes to build these solutions. And why do we feel that way? Well, really, we provide the plumbing, and we want you to focus on solving the business problem and not so much the underlying technical plumbing. So the ability to do logging, start and stop, exception handling, connectivity, security, things of that nature. And by providing a platform, we could standardize data access models through connectors, and we can also standardize security access models through connectors as well. And this should allow you to focus on solving the problem and not have to spend a whole lot of time on the actual plumbing. But we all know that there's going to be some limitations. Complex requirements can lead to complex solutions. And I like to look at this as the 80-20 rule, where low code can generally cater to like the 80% range. But then what do you do about the remaining 20%? And sometimes you hear the story of the remaining 20% is longer or more costly than the 80% it was. And that's where we feel we can help in this regard by offering some custom code extensibility. Now, why might you want to use custom code extensibility? There might be situations related to performance. So, for example, looping might be an example where you can execute those loops quicker inside of custom code. For some scenarios, maybe testability becomes easier in custom code, where you've got some logic and it's easier to sort of externalize that and then write assertions and test cases against it and provide more test coverage. And then there might be also scenarios around customer-specific IP, so intellectual property, where you want to be able to bundle this up and not expose the sort of raw underlying configuration to others. And so those might be all valid reasons for wanting to use some custom code. Now, historically, if we look at extensibility options, this is generally what it looks like, right? So we've got low-code platforms, we've got Logic Apps, and I would put Power Automate and Power Apps in that category as well. In the case of Power Automate, it runs on top of us. And, we've got these pro code options, and these are just a handful of them. We've got writing a web API inside of App Service. Perhaps we expose an API through API management. We can write Azure Functions, or we can run microservices, inside of Kubernetes. Now, generally what that means is now you're hosting your code elsewhere, which means that you now need to deploy another resource, which means you pay for another resource, which also means you secure another resource, which means now you monitor another resource. Now, if you think about the traditional IT landscape, now you're talking about, 3 to 5 or more copies of these resources. This complexity starts to add up, especially as you start to think of more and more solutions. So what's the option, or what's the alternative? So this is something that we did announce in October, mid-October, and this is .NET Framework Custom Code. And what this allows you to do is to write or author .NET Framework 4.7.2 custom code and call it from a built-in action. So when we say built-in action, we're talking about Azure Logic Apps standard here. If you have existing .NET Framework assemblies, perhaps you're doing a BizTalk migration, you have the opportunity to reference those assemblies inside of this model. And something that's particularly interesting, I think is actually pretty cool, is we create dynamic schema support for you, which means that when you go ahead and drag this, invoke a function in this Logic app onto your canvas, we will automatically draw that card, that action card, to include any input parameters that you need to provide to that method. Similarly, from an output perspective, when you try to use the data that's returned from the custom code, we will also draw that dynamic content for you in those downstream actions. So this is going to feel very much like a connector, in arguably even a custom connector in some ways, that allows you to really use this much like you would any other connector action. Now, another interesting thing, and this was another advantage of using this type of approach, is we can perform debugging and debugging of our workflow and our custom code in the same VS Code session. Trying to do that with say functions and Logic Apps historically has been quite challenging. That is no longer the case. That is now very, very simple. We've also included application insights integration. So this was something that we added since the public preview. And so what this means is you can go ahead and write your basically like logging statements in your custom code. When you deploy that custom code to Azure, you're going to see those line entries sitting inside of App Insights, and you're going to see basically correlation IDs that will allow you to follow through your workflow actions to your custom code and then back to your workflow actions. So we basically follow the breadcrumbs, we stitch that all together for you. Now, general availability, as I said, was already this in October, so we've been just over a month. We've seen some great uptake of using this feature. And the number one question I do get is .NET Core, and when is that coming, or is that coming? And stay tuned to the end of the presentation. So let's just do a very sort of simple hello world onboarding experience, and I'll show you what's involved in getting this to work. Okay, so I'm in Visual Studio Code, and I'm going to take advantage of some of the new features that Wagner talked about, more specifically around the Azure Write and being able to load the back-end runtimes, because I definitely need them when I use custom code, and that simplifies the process of getting this all running. So the first thing I'm going to do is I'm going to head over to the workspace, and we're going to use a workspace in this case because kind of what we have now is we're going to have a workflow project and we're going to have a code project, and we're going to use a workspace to kind of bind those two things together. So for those of you familiar with BizTalk and using Visual Studio and solutions, with your custom code project and your orchestration projects, this is going to feel quite natural for you. So we're going to go ahead and create this new workspace. Then we're going to go through a wizard-like experience. We're going to just create a folder here first. We're going to be asked to provide a workspace name, so we're going to just call this AIS a demo. We need to provide a function name, so this is the name of the local function we're going to call. I'm just going to go ahead and call this get weather. And then we need a namespace, and let's go with our old favorite Contoso. Now, we also offer the ability to create a sample workflow template that you can go ahead and use, and you can go ahead and name this whatever you want. We'll open it in the current window. So now what's interesting is we've essentially created almost like a template for you that you can get started. Like, you should be able to get this working within 2 minutes. And from there, then you should be able to tweak it to meet your needs. So let's take a closer look at what's been deployed here. So here's our workspace. And then, we provided that name. Then we've got our functions project here. And then what we have is below it, what we do is we do create a sample, basically code file for you. And here's where we go ahead and use the inputs that you provided. So we've got the function name is called get weather. We just have like a very simple method that sort of demonstrates some of the capabilities. So you can have a typical .NET inputs here. It's like strings, integers, can be complex objects. Then we're going to go ahead and return a complex object as well. And so if we look below, here's our complex object. Here we just have some arbitrary logic just to demonstrate this. We do some calculations, and then we return the value. Now, the other thing that we provide for you is inside of the CS_proj file, we have some build tasks. Now, these build tasks are particularly important. So we want to keep the workflow project sort of pristine. We don't want to deploy source code to Azure. So what we do is we get you to compile your source code. We have this build tasks that you see here on the screen, and we're going to copy the outputs, the assemblies, into our Logic Apps project. We will subsequently then go ahead and deploy that Logic App project with the compiled assemblies to the Azure portal. So what we'll do here is we're going to create a new terminal, and we're going to do that in the context of our functions project. We can now go ahead and just issue a .NET restore command, followed by a .NET build. And when I hit the build action here, notice what's going to happen to my Logic App project. So what's been added here is we have a new folder called lib, and then a subfolder custom, and then net472. We've got our custom DLL, and then all of the other assemblies, the dependencies that come along with it. The other interesting thing that happens, and this is really important, is that we've got a folder that has the same name as our function, and it's going to create or include a metadata file called function.json. The built-in action is going to use this file, this metadata, to go ahead and actually draw the inputs for the built-in action. And then it's also going to use this data for dynamic content downstream. So when we go ahead and try to use the output, we're going to see that we've got this object that we can use that's going to have all of these different properties that can be used in other parts of our application. So what we can now do is go ahead and open up our designer. And when we open up the designer, this is that sample workflow that we include. We've got the function or the action already pre-populated. Here we can go ahead and click on this drop down. This is going to enumerate any of those function.json files that exist. And you can see here that it's determined we've got 2 different parameters. Now, these are hard-coded, but they don't have to be, right? We can feed dynamic content to them if we wish, and I'll show you that when we get to the Azure portal. So at this point, we're ready to go ahead and do some debugging. So what we're going to do is we're going to start with the Logic App debugger, and we're just going to hit the play button. This will take a few seconds. And we know we're in good shape when we see this, right? We can see that we've got our trigger loaded. We also have our function loaded there as well. Next up, we're going to go ahead and just load the debugger for our .NET code. This is quite quick. We can see that this number is incremented to 2, so that's already wired up. So let's go ahead. Let's set some breakpoints. So we've got our custom code. So let's just set a breakpoint here, just arbitrary, doesn't really matter. And then let's go to our workflow and set a breakpoint here. We can now go ahead and load our overview page. That's probably the easiest way to go ahead and call this. Once again, we know we're in good shape when we see this URL loaded and we see the run trigger button. So let's go ahead, let's click it. And what we should see is our workflow breakpoint gets hit. And we can now go ahead and use the typical commands that you would see, like your F10s, F5s to step over, step through, etc. The other nice thing we have here on our left-hand side is our local variables. So we can go ahead and use that information. Now, one thing just to make note of is here we've got that application insights integration. So here you can go ahead and use the logger. And basically we've modeled this after what the functions team has done in their samples. So if you're familiar with that paradigm, this will be quite familiar for you as well. Let's just go ahead and we'll hit F5 and jump through all of this. If we head back to our basically our output, we can go ahead and click on this and basically our run history and see the inputs and outputs. So what we'll do now is we're going to jump ahead, not there, to the Azure portal. So what does this look like inside of the Azure portal once it's been deployed? So let's head over to the Azure portal. Now, underneath the hood, for those of you that might be familiar with like a data mapper and basically schemas and maps, like we do have an artifacts folder. We've extended that to include assemblies as well. And so here's where we'll go ahead and see where our assemblies get deployed when you go ahead and deploy it into Azure. Now, if we head over to our workflow, we are going to see that same action is available, and we can go ahead and configure it. Now, naturally, when you author code in VS Code. But if you did deploy, a set of functions, up to Azure, you could go ahead and configure them from that perspective. So that's what that looks like. We can go ahead and call this or run this. And I'm just going to grab a very simple sample message here. We can go ahead and run with payload, paste in that message body, and sure enough, here's where the output is. The one thing worth showing you just in that designer, I have this response, and this response can go ahead and use those outputs. So here's like the entire functions output, but here's those individual properties as well. And so that just allows me to go ahead and use properties from a complex object in my output. So I think that's pretty cool as well. All right, so starting to get a little bit tight on time here. Let's just talk a little bit about application insights. So I did show you that log statement, right, from inside of the custom code. And what we can see here at the bottom is when we run this in the local debugger in the terminal, you're going to go ahead and see that log statement show up here in the terminal output. Now, where this also shows up is when we deploy it and we have application insights configured for our Logic app, that we're also going to see it in the traces table inside of App Insights. And here in the message property, we're going to go ahead and include that information. Now, how you sort of link all of these things together is through the operation ID. So if you went ahead and this basically is like the run ID for the actual workflow instance. If you go ahead and query the traces table where operation ID equals that value, we'll then return the custom code telemetry plus any of the workflow trigger and actions telemetry as well. So you really can go ahead and stitch all of this data together if that's something you're interested in. Now, the next thing, and this is where we start to get into, okay, so one more slide, then we get into the surprise. So I think the question actually becomes, okay, when should I use this versus when should I use some sort of external coding paradigm? And I think it really comes down to like the requirements that you have. I look at this kind of in two ways. You've got a centralized model, which is going to have pros and cons, and you've got a decentralized model, which also has pros and cons. So I think it really, needs to come down to your requirements. So if you want to have a centralized service, like you want to say expose a function, and you want say many different applications to use it, including Logic Apps, then that would make sense in my mind to, provision an Azure function, offer it as a service, allow like other applications to reuse your code essentially. Now, the flip side of that is it's going to require more governance and coordination, and more specifically, dependencies, right? You have to now manage that. What if I make some changes? Am I going to break my clients? Then there's the decentralized model, and that's where you would have like your local function as part of your Logic app, basically what I just showed. And you can set this up in a pull model where you can still share that functionality, and perhaps you're using something like NuGet to go ahead and pull those common assemblies or libraries into your project, and then you can kind of use them. Now, the benefit is you do have fewer dependencies from that perspective because like the consumer is in control of basically the versioning. On the other hand, you do have some code proliferation. So like I said, I think both models are acceptable, but just think through your requirements and choose which is the best model for you. All right, so lastly, the surprise is, and I'm just going to let this play, if I can get this to play, is .NET Core is the the number one ask. And so that is something that we're working on. We are imminently about to release this in private preview. So if you like this idea of custom code, but you didn't want to use .NET Framework, you wanted to use something a little bit newer, this is the solution for you. And let me just rewind this a little bit. What we're doing to enable this is you're going to see the same onboarding experience that I just showed you. But the difference is you're going to have the option to choose whether you want .NET 6 versus .NET Framework. And based upon which one you choose, we're going to load the corresponding project for that framework version. We're also going to include the proper build scripts as well, so that when you are compiling your code, we're going to drop that into the right folder inside of the Logic App project itself. Now, I'll let this play a little bit. Now, the question is probably like, okay, why .NET 6? Where's .NET 8? So we will provide support for .NET 8. When we started to work on this this past summer, .NET 8 was still in preview. And so we didn't want to layer a preview on top of a preview. Now that .NET 8 is out, we will support .NET 8 in the near future. The benefit of like the model that we've built upon is that it is extensible, and we can now start to support other languages. If Function supports it, it's therefore something we can support quite easily. And so, do share like what your needs are in this particular area, and we'll see what we can do. So that's kind of my presentation. I'm not sure if we have time for questions. Otherwise, I'll take a look inside of chat.
There is no questions on the chat for that one, Kent. I think we did a really good job of showing that on the last months. but this I think is everyone else is going to be excited because I am with the .NET Core.
Sounds good.
Cool. And I think we are pretty much at time. And so let's add Alex again. And as before, now she's swapping hats. And I'll add Parakshit as well from our product group. And ready for you guys to start when you want, Alex. You probably will be
Yep.
sharing your screen.
I am just trying to find it here for a second.
Cool. And from what I understand, you're going to be running you're going to be running the slides, and then later on, Parakshit, you're going to be showing a demo.
I just have one slide that I'm presenting about announcements, but then Prisha is going right into the demo.
Okay.
Yeah.
So feel free to start sharing your screen now, and I just added to the stream when we need. Let's
Right,
add
whenever you
this
know.
one for you, and I'll get out of the way. The show is yours.
Alrighty. All right, welcome back, guys. So I'm here to talk to you guys a bit about Data Mapper. So for those who don't know, Data Mapper just became generally available, and Data Mapper supports XML and JSON formats and provides built-in mapping functions, a map checker, and a manual mapping test. So this exciting new visual data mapping and transformation tool is now part of the Logic Apps extension. So since we have merged into the extension from preview and become generally available, we now have a couple new features that we want to talk about really quickly. We've unlocked the function positions on the data map design page, so they are now movable to whatever liking you desire. And we've also updated the functions library to include various sequencing functions like filtering, sorting, and distinct values. Custom extensibility was also a big new change that we're really excited to bring. So we that kind of brings the ability to create custom functions, custom XPath, and inline XSLT. And then finally, we now have the test API available, which I'm lucky enough to bring aboard Prisha here today to talk to us about this exciting new feature. So Prisha, I will let you take that on whenever you're ready. Wagner, if you want to switch over to his screen.
Thank you, Alex. My name is Parikshit Gupta, and this is my first time presenting into this forum. I am one of the engineers in BizTalk, in Logic Apps team, actually, working on backend and runtime side of the things for Data Mapper and business process tracking, which Kent earlier presented today. Before starting to work on Data Mapper, I was actually part of BizTalk Server team since the release of BizTalk Server 2010. Today I'm going to talk about some of the APIs which actually runs in the background and powers the Data Mapper. And through my sample code, I'll demo some of the code which you can use to actually automate your testing of the maps and also compiling the map into XSLT. Let me go ahead and share my screen. Alex, can you confirm you see my screen?
Let's see.
No, it's not been shared yet. So you click Parakshit, you click on present, and then share screen. Then now it's coming, and there you go. Just adding a 2-stage. All yours. Inception effect.
Yep, thank you. Okay, so the code which I'm going to share today is already shared in one of the GitHub repository. This is the link, and we also actually released a blog article yesterday on the tech community about the same talk. The link to the repository is actually shared in the talk as well. So let's go and jump into directly what I wanted to talk about. There are actually 3 APIs which runs in the background to support the Data Mapper. First one is actually the Schema API. It's not very relevant to this talk, but anyway, I'll actually just give a brief overview of what this is. This actually resolves the schema, compiles the schema, and parses it to give the schema tree to the mapper to render and help in the mapping. The next API is Generate XSLT API. You can also call it Compile API. So the map is actually stored as in our mapping language format that actually not something which runs in the actual execution of the Logic app. So this generate XSLT API that compiles that map code into XSLT 3.0, and that is what is should be deployed and executes at the runtime. And the third and the final API is test map API. This API is used by the designer to in order to execute that XSLT against a given input, and the response is actually the output what you see in the mapper. So that is something we call it manual testing in the designer. But this talk is about how you can actually use some of the code behind these APIs to actually automate your map with many inputs. And that's what you need for, let's say, regression testing or making sure that your map is robust before you actually take it to production. So I'm going to share my Logic app, which is already in the sample. This is a Logic app project inside VS Code. And I already have some schemas and maps already defined. The thing which I'm going to show is how the API is started. If you actually first start the Logic App Designer on the Map Designer, the design time API is started in the background. You can see in the output window, the function host is started on port 8001. You can actually grab this port and start hitting the API from Postman, but I'm going to show you this can be started outside the VS Code environment too. All you need is actually function host file and local setting file. The important thing in these two files are actually, if you see, standard host.json file, but all we need to tell is load the workflow extension bundle, and the setting is this setting is enabled to true, so that we know that we are running it in the design time mode, workflow operations discovery host mode. And the local settings.json file has an important setting, project directory path. I'm going to tell you why this is important through my examples. This should actually point to where your artifacts folder for the Logic app resides. If you go and see here, this is my artifacts folder in the Logic app project. Schemas and maps, they're already existing concepts in Logic app standard project. There is a folder called map definitions where all my maps generated through data mapper. The new data mapper is actually stored. And there is a folder for custom extensions. If you see data mapper and the subfolder extensions, which actually stores my user defined functions and inline XSLTs. If you see my example map, I have used actually all three kind of custom extensions possible. When you need to use just a one-off custom expression, you can use XPath. Age is actually a user-defined function which is defined in one of these files, sample functions age. And another extension which we actually have is the inline XSLT. So both XPath and the custom function can generate just one value for a given node. But if you need to generate a structure and value together inside a node, that's where you can define your custom inline snippet, and this will take care of actually generating that full XSLT snippet or the full structure of the XML node behind in your map. So let me go and show the generated XSLT for this. The generated XSLT for this map is actually self-contained. If you see all my custom definitions, the user defined function age is actually embedded here. The inline XSLT, which was defined for this map, is actually embedded in the XSLT. So this is what is actually running when the Logic app runs, and this is self-sufficient. All these files, all these folders, map definition, inline XSLT, and the user-defined functions are only design time requirements. So none of these actually should go into the deployment. Only thing needs to be deployed is actually XSLT. And the reason this folder structure is required here is because the compilation process needs to know where my inline XSLT is, where is the definition of the custom function or the user-defined function. That's why we need this fixed folder structure, and the this setting, the project directory path setting is required in the local setting. So I can go ahead and now I have host.json and local setting in my working directory here. I can go ahead and actually start the function host to start the API outside of the VS Code environment. I've already gone ahead and started it. If you see, my working folder has both these files, and I've already started function host on port 8001. And if you see, this starts also an .NET Framework worker. So what we do is from the TestMap API, we actually invoke the XSLT .NET Framework worker where the XSLT is actually executed. And this actually runs the Saxonica .NET Framework XSLT engine, where we actually execute our XSLT 3.0. Let me go ahead and show you how the request and response looks for the TestMap API. If you see, this is my URL in the Postman. This is actually on the management head of the Logic app, and we are actually executing TestMap on a specific map, which is X12 to order JSON map. And the request body is simple, just one field, input instance message. Inside that, we have a content, envelope content with the content type, and the content is actually base64 encoded string. You can go ahead and hit it. This will show you that it is actually hitting the API, which is actually running for me outside of the VS Code environment. This is where it shows that executing the NetFX worker. And here is your output. So output response is actually, again, just one field output instance, and with the enveloped content. My map was actually XML to JSON map. So that's why you see the output is actually content type JSON. And the content is actually just base64 encoded content. The same thing I have actually given in my sample code to actually run it through an API client. All you need is actually, if you see Mapper API client project, all you need is reference to our NuGet package, workflow extensions. And I'm just using a simple HTTP client to hit the same URL. This is generate. Hit the same URL which I showed you in Postman. But the important thing here is that these are the two classes provided from the library, TestMap input, which is actually used to construct the content for this post. So you can take the reference of the NuGet package and start using these classes to create a client if you want. And the response from this API is actually deserialized into TestMap response class. So this is also similar to TestMap input class. It just has a field output instance with content envelope. I'm not going to run this API client. What I'm going to run is actually the code behind this API. I told you before that we actually start the .NET Framework worker behind this API, and that is what actually executes the XSLT. So what I have done is in the map tester project, I've actually taken a reference to another set of libraries which we can actually directly invoke the .NET Framework worker. So this is what is TestMap helper is another class I have provided in the sample. This is just constructing the input to invoke the library code, and there are a few things which are needed to bootstrap this class. I think one thing is you need to implement this interface and the host configuration interface, and you need a logger. And then you can start using this code to invoke the .NET Framework worker code, which directly executes the XSLT. I can go ahead and execute this code to show you how I've actually done some massaging around it. So if you see, the output is input and output is little different from what the API was expecting. The input is the content of the input is very similar. You actually have the input file content as byte stream, and map the XSLT path, the name of the map, and we just set this flag to to true that the code knows that this is actually coming from the map testing. In this test map API code, what we also do is we actually ensure that it executes the same code which will be executed by the workflow execution, so that you don't see the surprises when you actually execute the map in the test map environment, in the map designer environment, or you take it to the workflow execution. So the response will actually be same. The output from this code is a little different than the API response. If the output is XML, you get the content envelope response. But if the output is JSON, you get the J token directly in the body of the response. This is some small things to note about this thing. Let me go and execute this. So the command line is simple. It takes the map name, the XSLT file path, and the input instance on which you want to execute the map, and the output is dumped into this file, the student response file. So this doesn't go through the API. This bypasses the API and directly executes the code behind the API, and the input and output you can see is dumped on here. Okay, so the next thing I'm going to show you is some of the tests I have written for my sample maps, which I showed you earlier. Two of the maps, which is X12 to order map and X12 to order JSON map. So these are similar maps, but the output side in one case is XML, and output in another case is JSON schema. Both schemas are actually same. I've just ensured that I just wanted to show you some capabilities of the map code, but I'll come to that in the later part of the presentation. So the test project is actually on top here, the data mapper map tests. This is simply using the Visual Studio unit test framework. And the class is actually test class, and each of the functions are actually test methods. The way I have organized my test is actually by the map input output types. So one test is actually XML to XML transformation test. Another test is XML to JSON transformation test, but you are free to actually organize it in any other way. For example, it can be one test case for each of your map. And then each test case is actually driven by multiple inputs, and the test strategy is simple here. So I'm just executing the map against multiple inputs. This can take different map name also and different inputs. And the output is actually compared against golden output, which is already part of the project. The comparison here is simple. What we are doing is, in case of XML, we are loading the actual output and the expected output in X document, and using X nodes deep equals to actually compare that in case of XML. And in case of JSON, it's similar. We actually parse the expected output and the actual output into J token, and then use the J tokens deep equals functionality to do that. This kind of comparison will work if the map is deterministic, and it always produces the same output for a given input. But the problem comes, this kind of comparison will not work when you actually have some kind of dynamic content in the map. For example, you can actually have something based on current date time, or you might be generating a unique GUID or a different number every time. So this kind of comparison will not work, but yeah, you should be able to employ different kind of mechanism to test to validate your expected output. Okay, so I can actually now go ahead and run this test to show you how it looks in the text explorer. I've already run it, that's why you see the output, but let me go ahead and run it again. Just give it a few seconds. So you can see it runs, but there are some failures. In both test cases, one of the input actually failed. And you can go and see the output. It says the output comparison failed, and the output file is actually dumped here. If I go dumped in the output, if I go and show you the difference in the expected and the actual output. The difference is just in the one field. In the expected output, it is actually expected to be uppercase, but the actual output generated from the test is actually not uppercase. So I know I have to go and fix the map now. All I need to do is make the customer contact name uppercase. So let me go ahead and try to fix the map. So this is where the mapping language which we have come up with is actually handy. So coming from BizTalk experience, I know this is a big advantage, the ability to actually go and edit understand the map code directly and go and edit it. And the map code is actually designed with principles of actually having intuitiveness and human readability, and also uniformity across different formats of the input and output. So if you see these two maps, I told you this is XML to XML and this is XML to JSON map for the same scenario. You see both the maps look similar. In fact, they use the same construct irrespective of whether the output is JSON or XML. The generated XSLTs for them, you see, they're quite different, just because of the fact that output is JSON in one case. You see maps and arrays in case of JSON output in XSLT. In fact, the map code only differs in JSON and XML case only when the JSON arrays scenarios, because the way JSON arrays are represented differently from the repeating records in XML. So let me actually go and try to fix it. The map, I know if you get familiar with this map code and the language, and you know what functions are supported, it's very easy to go and update it. So let me go ahead and fix the customer contact name to make it uppercase. I fixed my map. Let me go ahead and run it again, my tests. Give it a few seconds. It still doesn't work. The reason now is actually because my code is actually running the XSLT, not the map code. So I need to actually go and compile this map again to get the new XSLT. So that's where the second API I told you earlier, the generate XSLT API or the map compile API comes handy. So let me show you how that API request response looks like. This is my generate XSLT API path. This is on the same management URL head with generate XSLT path. And the request is simple, just one field, map content. The content of the map code goes as a simple string in the request, and the response you get is the XSLT, the compiled XSLT content as a plain string. The same thing again, I have actually in my sample code, I have this done through an API client in the same code, and there are the classes to actually support input and output for this API. So generate XSLT input is the class which is used to construct the content for this request, and the response is actually deserialized into generate XSLT response object. This is just few tips and tricks to use the API client for this API. Again, I'm not going to run this API, and what I'm going to show you again another code in the project generate XSLT, which is actually using the code behind the API, directly using the library from our NuGet package. So this is again we have taken reference to the NuGet package, and all we are actually calling is generate XSLT on the data mapper utility class. There are a few things needed to bootstrap before we can call it. There are a few statics to be initialized. You need to initialize flow configuration. And again, earlier I said project directory path is important for the compilation process because it needs to know where the custom extensions code exists so that you can actually go and the compiler can go and find out those things and embed those things in the generated XSLT. So let me go ahead and quickly execute compile my map into XSLT. I have it. This is for the JSON map, XML to JSON map. And this is for the XML to XML map. So now I have actually my map compiled. If I go ahead and execute this test now, give it a few seconds, this should now pass because I actually have the updated XSLT for these maps. This still fails. Okay, I think this is not expected, but yeah, we can go ahead and fix it. What I wanted to show you another thing was for this change which I did for my map, I went ahead and actually raised a pull request into my repo. So if you go ahead and see the pull request for this change. So irrespective of whether you actually change your map, either in the designer or in the map code directly, if you actually take that update through the code review process through pull requests, you can actually identify the logical changes in the map and ensure that the changes were done right and really take the full advantage of the map code and the new mapping language features. Yeah, that's what I actually had to share. Back to you, Alex.
Yeah, thank you so much, Prisha. That was perfect timing. We're at 3:35. Wagner, was there any questions for Prisha or I?
Sorry, I was just coming back to the stream, so I didn't mess up with anything. No, we don't have any questions on that. It was quite comprehensive session. I think it's people was amazed with the things that we could do with that one. So the questions that we only had one question here, but it's not related to service bus. So I'll answer that one offline. Parikishi, thank you very much to join us. I said it was really good. We always get like a lot of good feedback when you bring the people that is actually doing this stuff instead of just us the PMs that talk about it on that. So thanks for joining us, and I'm pretty sure that people is going to be coming back to that testing one. And I'll be host for one time, Alex. So you can breathe between your sessions. And on that note, I think I'll bring Divya to the stage. Thank you again, you two, for that.
Thank you, everyone.
My machine is super slow. Okay. Okay. Okay.
Is my audio okay? Can someone confirm?
Yes, we can hear you okay. And just let me add your slides because it's super slow, my interface today.
Okay. We are good now?
There we go. Can see. I'll jump out of stage and all yours.
All right. Thank you. Yeah, excited to share the platform today with Parth to talk about AI investments for Logic Apps. And to begin with, we will first talk about Workflow Assistant, which is a recent release we announced at Ignite, and it is in public preview now, which basically provides you a chat interface that helps answers any questions you have regarding Logic Apps, connectors, scenarios, best practices, anything, all within the designer and in the context of your workflows. what we've done is basically we are using several knowledge sources of Logic Apps and curating that information with the power of OpenAI and ChatGPT and bringing this wealth of knowledge at your fingertips. So with that, I will not be spending too much time on slides. I want to jump directly to the demos. But before I do that, I do want to make this session a bit interactive. So I would really appreciate if folks can use the link, the poll everywhere link I have here, and either join it from their web browsers or their phones. And I'll just have a few questions while I'm doing my presentation. If you can provide your responses, share your feedback, that would be great. And for anybody who is watching this session afterwards as a recording or and wants to reach out to us to talk about AI, I have a link in there. Please feel free to reach out because this is an evolving space and we would love to talk to you. So with that, I am going to jump to the demo. But before that, I need to do something very quickly. Sorry. All right, we have some. Give me 1 second, please. All right. And all right. So hopefully I have started the polling now. So if you can go to that link, you will see some questions. And if you can provide a response to that while we look at the demo, that would be great. So let's jump into the demo. And what I have here is a Logic App standard workflow. Currently, Workflow Assistant is only available in Logic App standard and only through the portal. So not yet available in VS Code. So we will run through a couple of use cases through different kind of questions in this demo. So to start your workflow assistant, you basically open your workflow, click on this assistant here, and it already shows you some examples on how it can be used. And let's use the first example here. So I am going to ask what this workflow does. As you can see, it's a very simple workflow, which is basically trying to run some Custo ADX queries and pull the data from there. So let's see what Workflow Assistant comes back with. And as you can see, the response from this from the Workflow Assistant gives you details of each and every individual step in this workflow and provides you a lot of details on what is happening within each step. If you look at the actions I have to run Custo queries, it actually goes into the details of what the query is doing, how the results will be rendered, and provides all of that in explanation. So this is a very useful way when you are trying to collaborate on workflows that are not just built by you, but are others, or you are working on something that is passed on to you and you really want to understand what it does. So a very effective way to learn what your code is doing. This also can be a good starting point if you want to create workflow documentation, where you can simply leverage the content from the output of this action and persist it in your workflow documentation. And on that end, I do have a question as well for you. And please see if you see any value in there. So basically what I'm trying to ask is, like, if we provide an ability for you on what you just see in terms of describing the workflow to download it as a markdown and put it in your GitHub repo or other places, would that be a useful feature? Would that be a useful capability that you would use? So now that we know what this workflow is doing, let's ask a little bit more specific question and see why or what is the purpose of scope in this workflow. As you can see, it returns the response back and very concisely explains you the purpose of the scope, which is primarily to group the actions together and encapsulate them so that you can manage them easily. So when you have workflows, you can ask very specific questions, not just about the workflow, but about individual areas in the workflow where you need to learn a little bit more on what the purpose of those steps are or what they are doing. Now that we have asked some specific questions, let's ask assistant about some specific features. So I want to add some tracked properties, and but I don't know how to do that. So I'm asking some questions around how do I add tracked properties to the workflow. And again, it gives you some on how you would do that. And in fact, it takes an example from your workflow, parse JSON action as an example, and also suggests you how you can use the output where name is one of those properties from the parse JSON action and use that. Now, in order to add this tracked property, I need to have an expression. So let's ask Copilot if it can help us build that expression. So going to ask if I can get some help on building the expression. So the workflow assistant provides you the response with the exact expression that you can use to add a tracked property in this example and use that. So I was trying this before, but let's try to add it again and use the output that came from my workflow assistant. Do a save, and this would basically add this tracked property, and wherever you are emitting the logging, this tracked property would be emitted along with our default telemetry. So you probably have done this before, but with workflow assistant, if you're new to the platform, or it can simply help you to pull in the expressions for the value of these tracked properties very quickly, where you don't have to do that exercise of going back to the outputs and looking at everything. You simply provide it a question in natural language and get an expression and use it here. Now, I think I am done with this workflow. I'm ready to test it. And so I'm going to ask a question around how I can, test this workflow. So I'm prompting the assistant to provide some example on how I can test this workflow. So this is the workflow assistant gives an example JSON, which can be used to test this workflow, right? So I'm going to use this. And you can see that it also tells you that you can replace the name, company, country, which are the keys here, with any kind of values or desired data that you have. So I'm not going to go into the testing aspect of it, but just by but you can. I think this is a very powerful feature where once you build the workflow, you can simply use the workflow assistant to generate a different type of sample payload to test your applications. And while I asked this for a workflow, you could also ask the same question for specific steps if you are interested in testing some key things in specific steps as you're building the workflow. So instead of workflow, you could simply put the name of the action, and it should provide you, based on the schema, what that sample payload could be like. So I think with this, I wanted to demonstrate that you can use Workflow Assistant in the context of your workflow and ask very specific questions, both high level in terms of how something is happening, and go deeper down and ask very targeted questions on specific features, and then use that response to build your workflows iteratively. As well as when you're done building, you can also test Workflow Assistant, test your workflows with using the assistant. So now I'm going to go back to something where I'm starting from scratch here. So I don't have anything. And at this point, you're trying to figure out how to do certain things in Logic Apps. And one of the examples that I'm going to use is with so many connectors and so many possibilities, one always needs to do some research in terms of like what connectors to use. And sometimes you start with a very high level problem statement, right, where you want to connect to some ERP, and what kind of connectors are available in Logic Apps. So uh, here I have asked a question around provide the examples of ERP integration scenarios using Logic App connectors. So I'm not even going into connector examples. I wanted to see if Logic Apps can actually support, scenarios, ERP integration scenarios, and it comes back with a lot of examples on what kind of ERP scenarios you can build using Logic Apps, and how not just one line scenarios, but it also gives you an example that you can trigger on the inventory levels if some threshold is used. So you get really comprehensive details in terms of how you can go about building those end-to-end scenarios and applications. So now that we know that Logic Apps does support these kind of scenarios, let's ask a little bit more specific question on what are the different connectors available for these ERP applications. And this is again, I think, very useful when you are exploring the connector ecosystem, and in many cases you know exactly what you want to connect to, but if you are in the exploration phase and want to see what product supports out of the box with built-in connectors, you can ask these kind of questions and get a response which gives you an idea around the product capabilities. I did move to another question on the poll everywhere. So, and I want to understand, like, as I'm going through these use cases, if this meets your needs, what else would you like to see for us to bring in, AI capabilities? So anything that comes to your mind, please do provide feedback. Along with this, you can also use Workflow Assistant here to learn some of the learn more around standards. What are the best practices, for example, for handling errors in Logic App workflows? And this should again provide you some standard practices in handling errors, for example, using the scope action, implementing retries and exponential backoffs, using run after the scope, terminate action if you want to stop the workflow execution. So lot of curated information, all brought together in the context of your question, so that you have all the information at your fingertips to make decision on how you want to build these workflows. We also realize that a lot of customers are moving from other platforms, including Logic Apps. And so you should be able to ask questions pertaining to those platforms as well. For now, probably not other platforms, but definitely for BizTalk, where I've asked a question on how I can use BizTalk maps in Logic Apps to transform the data. And it tells you exactly what action you can use, and that you can leverage the same map in Logic Apps as well. I could actually go into deeper and ask step-by-step guidance on how to use that map, and in the response you would see that it provides you detailed step on how you can do that. So I think I did cover most of the scenarios that I wanted to. And before I move to one last feature, I did move to another question on my poll. If you can look at some of the things we are hearing from customers, from like yourself, what is important for you, and if you can order them based on what's important for you from top to bottom, that would be great. So while we have the data model that we are using, we have spent a lot of time and effort to train it so that it's safe and reliable. So if you ask questions that are not related to Logic Apps, you should get a response that it's outside the context, it's outside the scope of Logic Apps, and it should not be able to respond to it. And finally, as you all probably know, that we also have Azure Copilot. So if you ask any questions that are outside the scope of Logic Apps but within the scope of Azure, then we are going to do a decent handoff between Workflow Assistant and Copilot. So if you ask any such questions, you should be able to see this experience where you can open Azure Copilot and then continue there for your non-Logic App questions. All right, so I think that's all I wanted to cover today in the demo. And I did share the link with everyone before, so would love to hear feedback as you see this video afterwards, or if you have any questions, please do reach out to us. So thank you.
So Divya, we do have a few questions, if that's all right. If you want to defer this question, we can defer it as well. So why is this branded as Workflow Assistant and not Copilot?
Sorry, I think I should first stop sharing my screen so that I look in the camera. All right. Yeah, I think that's a very good question. It's just a point in time thing. We do have intention to converge with Azure Copilot. It's just something that we wanted to get something in the hands of customers soon. And we are working on that convergence story.
All right, this is interesting. Can you please extend the assistant to also look into the configuration settings? So it would be good to better understand what sort of settings people are interested in. But has that come up at all, just in terms of configuration settings?
I think I'm assuming they are referring to the Logic App work settings. And so I definitely see value in it, and it does come up as things where they would like to see this assistance. So definitely something that we would consider.
Cool. And there's one more, another convergence question. So Power Platform has a Copilot which creates the flow based on requirements provided in natural language. Can we expect the same from Logic Apps in the near future?
Yeah, I think that's a great question, and we actually did consider what should be the scope for our first release, and we did talk to a lot of seasoned developers as well as new developers for our platform, and we decided to go a little slow because we all heard from people that if you generate a workflow out of the box with like 50 steps and I don't understand half of the steps of that workflow, I may not be ready to use it right away. So we are trying to understand that we want to understand this use case better, that what do you expect when you want to start from scratch. And for simple scenarios, I think it's all good, but you definitely want to use Copilot to help you with more complex scenarios. And what is your expectation that AI should respond you with, and how would you further interact with it after we give you that first line of response? So I think Misbah, this is a great question. If you have any further thoughts on it, please do reach out to me, and I would love to talk to you as well if that works for you.
Sounds good. So that's the end of the questions. There was, when you did pause earlier, and we're talking, I believe, about like being able to store information in GitHub and be able to leverage it. There was a definitely yes response by Misbah as well, but that's in the chat there too.
Yeah, that's great. Thanks for the validation. Yeah, something we are looking into right now.
Okay. So I think that wraps things up on this session.
No, we have Parth.
Did have one small demo. on.
I'm sorry, my
No
mistake.
worries.
Yeah, Parth, let's go. My
All right,
bad.
were you able to see the screen? All right. So I'll quickly go over a use case for Logic Apps. That is, we've been helping people to build the workflows using workflow assistant, but how can you create even workflow assistants by yourself, right? Especially with retrieval augmented generation pattern. This is something which is a standard industry pattern, especially let's look at a real scenario, right? And we'll look at, after that, a small demo as well. There we go, yeah. So Contoso wants to be able to give a platform for employees to ask questions about their benefits. In this case, that's insurance, right? And they want to give this end-to-end experience that includes, any kind of information that they need. There is a demo sample that we'll be taking a look at from Azure OpenAI. But the main idea here is that we'll take a look at what the current scenario looks like when you build these kinds of models and end-to-end applications. And second, like, how would you use Logic Apps for this scenario, right? So when you're looking at this concept, there are two components rather, right? The first is the offline data ingestion, in which you are taking the document, you are going to be indexing it into the vector database. And within that, you need to make sure that you are also creating the embeddings, tokenizing, all those operations, right? Which one has to write code for today, right? Similarly, the second component is the chat experience. So when text comes in, like, how do you find the relevant documents depending on the prompt, right? For chat experience, like, you use the LLM to search and query based on the prompt. So when question comes, you break it down into embeddings, which is what the LLM computes, and then search using those in the vector database, right? Creating to create the prompt context and then respond, right? At the end of the day, to the client application. So this is a quite arduous process, even though there are just two main components. And how does it look like without Logic Apps? You need to write a lot of code for these building blocks, right? You need the connectivity, you need the authentication. You also need to make sure that these operations for tokenization, getting the embeddings, calling all the endpoints for OpenAI and AI search should be resilient and reliable, right? So in this case, like, all of this becomes very quickly difficult to handle, especially when you look at the ingestion pipeline. You have a lot of these Python code scripts, which we'll look at the sample in a second. At the same time, you have the backend as well, which is quite complex written in Python. And with Logic Apps, though, it would be a different game with the building blocks, because we are planning to announce two new service providers for Azure OpenAI and AI Search as building blocks. So you can communicate with these services and make sure that you are building the workflows and only focusing on business logic, right? And not quite having to write code for all of it. When you look at the workflow, it's going to be, for the ingestion workflow, you have a PDF that will be broken down, will be tokenized, in which you to generate the embeddings and then search, index it in the vector database, right? Similarly, for the chat workflow, you need to make sure that when you get the prompt, you create the embeddings so it's readable for the vector database to search from, and then you get the related segments and send the response, right? So for that, like, there is a quick demo for both of these flows. I already have the ingestion data flow created here. In this case, like, I have an HTTP trigger which triggers the workflow and gets the document. But think of, like, the amount of triggers we have, right? We have the event-based trigger and the recurrence trigger as well, in which if you have, let's say, OneDrive or SharePoint, and you're uploading files in real time there, and you want to ingest them, you can do so with those triggers, right? When you are ingesting this, the flow looks pretty simple, because you have to compose the inputs and call the tokenize function. This has a lot of code written behind the scenes. In this case, I will try and just generate, I can find the code really quick. I don't think, but idea is that like we have written a function in this case, which is calling, which is being called from the Logic Apps. And we're passing in the tokens, and we plan to also make this operation as a built-in operation rather than having this right now, right? So idea is that you have to, again, write code for this in real life. And after that, you have to convert it to the particular JSON schema that can be called for the open AI endpoint to get the embeddings. Once you have that, you are then going to index the documents. And before I show the indexing operation, we already have an Azure OpenAI search, right? So it has these particular document name and other metadata information that is required. And then in this case, you just create that particular content with the expressions that we have. And as Divya was showing, like you can easily leverage like the workflow system to even help create these operations. And then, yeah, once you have that, you are able to simply pass it into indexing the documents, right? And when we trigger this flow, let me just see if I can run it, which is just a API endpoint call right now. So let's see how quick it takes for this to execute, and if it does. So yes, so within seconds, right, like you are able to whip up this entire logic, put it into a canvas, and like even see the status and see like at what point if you want to debug and make sure that the whole ingestion pipeline works seamlessly, right? You are looking at like all of the features that Logic App has for checking the inputs and outputs. And once you have this ingestion flow working, there is something that I wanted to show for the chat workflow. But before I show that, I wanted to quickly show you the sample for which you have to chat with, right? So this is the sample in which we are ingesting to all the data into. And you have this prompt that you can ask, hey, does my plan cover annual eye exams? And it should respond in real time. So in this case, Azure Cognitive Services has, all the resources for us to compile the system messages. When you receive the prompt, right, you are trying to generate the search query. And even upon receival, it's a simple HTTP request trigger, which you can accept the prompt type as string. You generate the search query, right? You train it with some sample responses. And once you get the search query and convert it into the embeddings that through which you can search the vector database, you are then creating the final prompt. And that's, again, just a few JavaScript inline code actions for even generating the search query and creating the prompt. And you are calling the open endpoint to complete the chat and send the response, right? Yet again, these are the two new connectors that we will be releasing by next year, you can expect. So definitely let us know, and I can quickly trigger this as well. As you saw in that example, we want to ask like, hey, for this particular document that I ingested, does my plan cover annual eye exam, right? So I'm just gonna use HTTP request with payload. And run it. Yes, so you get the response, you get the citation. So yes, you are able to quite easily orchestrate for not just from the client front-end side of things, but also especially from the ingestion pipeline, and make sure that you are able to ingest data pretty easily, right? So that's all I had. If there are any questions on this, would love to entertain them. If not, we have another demo lined up for using this chat plugin, experience with Logic Apps.
Yeah, thanks, Parth, and sorry about the preempting there earlier. No questions currently, but folks, if you do have questions, do feel free to put them in chat, and Parth will be watching it to respond.
Sounds good.
All right, thanks, Parth. We'll bring Alex back to introduce Govind, and this will be the last session of the day, I believe.
Yeah. Alrighty. Well, thank you, Parth, and also thank you, Divya. And Govind, I'll hand it off to you to talk a little bit about Copilot.
Sounds good. Thank you, Alex. It's been a long day. I'm sure everyone is probably like tired of so much information. I'm gonna try to do my share, but take it, in stages. So let me share my screen. Gonna see the. Okay, here we go. All right, cool. Hello, everyone. So my name is Govind, part of our global black belt team. Essentially, what that means is we focus on a few areas. We're essentially an extension of engineering in sort of more customer-facing role. So I'm here to talk about how you can build, these reliable copilots with Azure Integration Services, and kind of showcase. I have a demo with Logic Apps that kind of grounds the copilots with more reliable output. Okay, so let's kind of talk about the elephant in the room here, right? So Azure OpenAI is kind of like a black hole, especially with its generality and capabilities. It's definitely sucking up a lot of apps and data. But you just saw Parth do a demo of RAG, which I feel like every application right now is somehow doing that. They're round tripping with these LLMs. But what we're also seeing after you implement that Hello World RAG is how can you extend that LLM sort of reasoning, large language model reasoning, to your workflows, as well as your systems of record behind integrations, right? So I'm going to explore that. Now, before I do that, just at a high level, the model that we currently have, sort of the GPT-4 Turbo that just got introduced, it has a lot of capabilities. And the fact that it is so general purpose and can be used in so many use cases is one of the reasons why there's so much hype, right? You can pretty much, have it generate first drafts, create personalized content, generate code. As developers, we all use GitHub Copilot. You saw a demo of Azure Copilot, right? But it also has a lot of limitations that you want to mitigate. And that's where the retriever system kind of comes into play, and also how you structure things and how you integrate with your other systems kind of come into play. There's a lot in this sort of chart, but what I want to highlight is that the emergent capabilities are what you want to adopt, while also kind of mitigating a lot of limitations, right? It cannot plan. It obviously doesn't have common sense reasoning. It's not really goal seeking. So you need to kind of introduce that in your applications. Now, the capabilities just keep on getting better and better. This is somewhat outdated but it's a paper by OpenAI kind of capturing that with more data and compute, how these capabilities just emerge, right? So we're on this sort of exponential curve here of with every model iteration, there are just more use cases where you're going to integrate these models. So there'll be more and more, essentially every app is going to be an intelligent app, right? And certainly OpenAI and Azure are kind of shaping and pushing the frontier here. If you look at a lot of the open source models, GPT-4, as well as sort of 3.5, certainly are like the North Star here. This is actually, this paper just came out this week, kind of documenting in several sort of, dimensions how much capable it is. So pretty much, most use cases that you have, there's a value in sort of integrating and round tripping with this. And the way we do that in Microsoft, we've shipped a lot of copilots. Pretty much everything we ship now is going to have this experience of like a copilot. Is we have a stack behind it. And while this may be a architecture, concretely, it's actually made up of services, and specifically even integration services, right? Of course, there's sort of open source SDKs that we have sort of made available for other customers, but we're also helping customers use Azure services to build these copilots, just as we're dogfooding our own copilots with them. So at a high level, like if you think about it, you want if you go and ask ChatGPT right now about your sort of proprietary domain information to synthesize or reason over, obviously it won't know, right? So you need to ground that. And to do that, there are several ways to do that. And I've kind of overlaid this in terms of how well you can sort of ground. So you can probably, if you want to something kind of quickly start, you can use Copilot Studio, but you'll discover that you might need more control. As developers, we often do with the use cases that we work with. So there's APIM that can also kind of be the facade for your sort of plugins. And I have there's actually a colleague of mine, David Barkle. I don't know if he's listening, but he has a great demo of this that you can also check out. But what we're going to focus here is Logic Apps, which essentially allows you to take any complex workflow and makes it available as a plugin. So we'll see that in action. So that whether it's Microsoft Copilots or your own Copilots, you can kind of ground them. And as you orchestrate, you're going to realize that in this sort of retrieval augmentation, the retriever system becomes very important. And of course, there's persistence layer that certainly grounds that. But a lot of folks will realize pretty soon that there's a lot of information behind your software systems, as well as your SaaS applications, maybe like a Salesforce or SAP or mainframe, etc., that you can kind of unlock with Logic Apps and its connectors easily. So let me just kind of continue and before I go to the demo. So I think we've established that plugins are kind of how you're going to ground the Copilot, and the experiences that you're going to build, will require integrations with these authoritative systems of record, and they have to be, reliable and trustworthy, because ultimately, the proprietary Copilots that you build have to kind of ground themselves in data that is hidden behind APIs and databases as well. And of course, you want them to be scalable, evolvable, as well as security needs to be kind of embedded in the retrieval and system and access patterns. So that's where our integration services kind of come into play. So I'll do like a quick demo. And the idea here is, you probably have Microsoft Copilot or your own Copilot, for example, M365 Chat or Windows Copilot, right? They all support this interface called AI plugin. And in this case, you can take your existing Logic app, and that endpoint essentially becomes a plugin because it has a wrapper for that AI plugin essentially abstraction that it looks for. And in the Logic Apps workflow, you can do a more reliable sort of retrieval, right? You can retrieve, I think earlier in the demos, you saw how easy it is to drop in these connectors, whether it's connectors to your persistent systems or your other APIs as well. And then you can even further use a reasoning engine like OpenAI model or even like a proprietary model. And then I kind of call them actuators, but you can also have it do other actions, like maybe notify to Teams or email connectors and things like that, right? So let me kind of go to my screen. So in this sort of example scenario, I have a somewhat simple workflow where it kind of accepts a request, and then I'm constructing a prompt as I sort of aggregate more information for the context. So I'm kind of parallelly retrieving some information from Cosmos DB. So this is like an example of, think of it as like a support person trying to assist a new employee or an employee who's looking for like a laptop refresh, right, for example. And in this case, I need information about that employee. So that might be in a different system, right? In this case, Cosmos. So I'm using Cosmos Connector. And in addition to that, I might have to retrieve some information about my knowledge source. So I go to, and by the way, right now I'm using a REST endpoint, but Parth just showed the connector that's going to be built in to Azure AI Search. And then I parse the relevant embeddings, and then I get the relevant chunks, and then basically, I call the large language model to synthesize, and then respond back. Now, this is, nothing special about this. It's just a typical workflow. But what you can do then is essentially take the endpoint that that you can access from the overview blade, and you can go to, either you can go to your own Copilots. So this is a sample app from the Semantic Kernel project. Semantic Kernel, by the way, just a quick side note, is our orchestrator that's powering our Copilots, and it's open sourced as an SDK for C#, Java, as well as Python that you can use on your apps. So in this case, it's just a Semantic Kernel sort of sample app that allows you to add plugins. So it's kind of like, you can also, for example, let me just show a quick sort of demo here of how this might work if you procure your own Copilot. So let's say your company, procures the Microsoft 365 Copilot, right? And like I said, everything that Microsoft ships now is going to have some part of this. So like, for example, here I have, Windows Copilot, which also has this concept of plugins, but I'm just going to stick to this one. So what you'll eventually have is, it's in preview now, but, imagine next year it's going to be more mainstream, where you'll be able to add these plugins that will kind of ground the Copilot's responses as it synthesizes information. So you can kind of, go to this plugin store and you can add more plugins, etc. Right? So now if you have a Logic Apps workflow, you can just copy that, just the endpoint itself. And here, I'm just going to refresh my custom Copilot. And here I'll just start a new session. And then all you do is you can go to plugins, and you can already see some existing plugins here, right? I'll add a custom plugin, and then I'll just paste the Logic Apps endpoint that I deployed, and I'll hit Find Manifest. And as you can see, it'll first verify the plugin that it conforms to OpenAPI spec and that it has an OpenAI manifest. It does. It's got a built-in. So now the plugin is there. Now I'll enable the plugin, right? And then now I'll just ask a question like, so imagine I'm like a support person trying to assist an employee who wants to refresh their laptop. So I'll just say, John wants to refresh his laptop, right? So this custom Copilot Semantic Kernel has a concept called Planner. Basically, what it did was it intent detected what I'm trying to ask, that the goal is like John is seeking to refresh his laptop. But then because I added that plugin, that's basically a Logic Apps workflow that has an endpoint and a description of what it does, it realized that, oh, rather than me hallucinating and answering something about this, right? Like if you go to ChatGPT, it might just answer something, right? But because I enabled this plugin, it's actually going to, in this case, I'm actually adding human in the loop to proceed with the plan or no. But I could certainly remove that. But what you can see here is that it kind of broke that down and kind of put that topic in this sort of JSON, right? So the payload topic is refresh laptop and the username is John. And then when I hit proceed with that, now what it's doing is it's actually executing that Logic Apps workflow, which is just a REST endpoint, right? With that information, and that actually goes to LLM and does further synthesis, goes to Cosmos DB. It's aggregating information from Azure Cog Search about the refresh policy of the company, right? Gets information about the user from Cosmos DB, and then it does a bunch of things like notifying through Teams or notifying by email, or even creating a support ticket and things like that. So, and then it responds back, and then it synthesizes the response and answers back to the user. So this flow, you're going to see a lot more, especially as you start using Copilots from Microsoft. Like we have a service Copilot, we have a sales Copilot, right? Or if you build your own Copilots, like with Semantic Kernel, as you see here. Now, you can also, of course, have more complex stuff, right? Like you can have the retriever system in RAG is very important. And what customers are realizing is that information is just hidden behind many systems. In fact, I think a typical knowledge worker interacts with something like 8 or 10 systems every day. So there's a lot of information behind these systems, right? ServiceNow, Salesforce, etc. Now the cool thing about Logic Apps is you can essentially kind of parallelly retrieve all that information hidden behind so many different systems and kind of aggregate them. And if you want, you can use LLM again to kind of synthesize that or summarize, and kind of take action on them as well, right? Like maybe, of course, posting a feed to Teams or emailing, or even like creating a new Jira ticket. In this case, let's say if the user needed a laptop refresh, it can automatically, kind of like an agent, automatically create a ticket in Jira. I obviously don't have Jira access, but you get the point. Or even send an event to Event Grid, and that can take action on something, or service bus, right? Run some reliable transaction. So there's a lot that you can, kind of do there, and these patterns are slowly emerging, as customers kind of mature and kind of go and see where else they can apply these reasoning engines that are so capable and powerful. So as you can see, you can really simplify the complex with Azure Integration Services. What you just saw, I actually even kind of compressed the amount of interactions that happen behind the scene in Logic Apps that I was quickly able to kind of drag and drop and configure. But for these copilots, you can essentially ground them by, with Logic Apps as plugins. There are other use cases too. I have a sample app where I'm trying to kind of actually, this is from a customer that I'm working with, and I tried to generalize it and put that in a sample. But basically, you can use sort of LLM as a reasoning engine to reduce cycle time for your tasks in your workflow. So in this case, let's say you want to do some asynchronous sort of processing involving a large language model, right? Oftentimes when we talk about these copilots, we're talking about synchronous interactions where a human sort of, and especially over a chatbot. But I think that's going to evolve again to, infuse these AI sort of everywhere, right? And let's say, for example, every, again, I would not recommend this, but let's say you have $100 and you want to optimize the investments or the allocation of that $100 on a daily basis, right? So imagine if you're like a trading desk. I think, the model capability right now, we all know that it can hallucinate. So that's why I'm not recommending, but you can imagine that with a human in the loop, you can certainly generate sort of recommendations here. So let's say, with Logic Apps, you can kind of set up a timer, right? Where every day when the stock market is open, you can sort of aggregate information about the user's preferences, their stock investment, your, information that's hidden behind mainframes or other source systems, your investment thesis information, current inflation data, all the information that is needed to make a decision on how you should allocate, stock, how you should allocate money, basically, right? To get a better return. So all that with Logic Apps, you can kind of parallelize and aggregate all that information. And then you can use something like, semantic kernel with or Azure function that is embedded in the Logic Apps that can kind of call the large language model or directly call LLM. And then you can further sort of get approval email flow. So you'll have human in the loop. Like you could say, hey, maybe today you might want to sell some NVIDIA or, invest 10% more in Microsoft or something like that, right? And, with Logic Apps, you can kind of easily kind of do all that sort of in one shot and have that run, asynchronously sort of every day. And then if they approve it, you can reliably execute that with like a service bus running the transaction. So you can envision in all kinds of scenarios where LLMs could be embedded to kind of improve task efficiency. There are actual use cases too that we see here. This is another one from bank, where again they're using the semantic kernel orchestrator. I think I'm running out of time, so I'll try to go a little bit fast here. But what you see here is sort of a bank representative using their Copilot to help a customer on a new bank loan. So this is similar to that customer service rep, helping a user answer some support-related question, right? So you can use a combination of Logic Apps to use some CRM connector that can, do like on behalf of user flow to ground the model. And you can also use API management as well. to like for the plugins to kind of again improve that secure access patterns. So there are more use cases similar to that. I think in the interest of time, I'm going to try to kind of showcase some of the other capabilities. Now, the plugins that we talked about, again, we said everything that Microsoft ships is going to have this Copilot service. So M365 Copilot that you just saw, or Windows Copilot. This is kind of how they work. You know, you might go from a natural language question like, hey, do I have any work assigned to me? Now, the Copilot service is actually going to first always fetch the plugins that it has. Actually, it'll first intent detect what the user is asking, and then it'll go and get all the plugins in the plugin catalog. So these are just some examples, but you can think of having your own sort of Logic App workflows or plugins that are wrapped with APIM made available. And then once that's sort of done, it can generate a plan and execute a plan with that plugin, right? So that's kind of how these copilots work behind the scenes. And they really extend the value of our copilots. Like so, especially next year, as you see more and more adoption of these, Microsoft 365 copilots, you're going to see a lot of investment in plugin development. And I think using Logic Apps is just going to make it super easy to quickly get started with and put a plugin out there. A plugin that is actually like super advanced, right? Because you have all these connectors that can really expand the organization knowledge, right? Like imagine writing a connector for like mainframe or even ServiceNow and things like that, right? Like you just have to. There's so much to deal with that makes it easy with Logic Apps. Again, a lot of SaaS providers are already building plugins for the Microsoft Copilots, so I think it will be more mainstream. There's a lot more that Azure Integration Services kind of offer to improve quality attributes or non-functional requirements when it comes to copilots. I think, of course, you have scalability and interoperability as well as workflow automation that you can achieve, right? We talked about retrieval, augmented generation, but maybe you might want to also transact and run them reliably, a combination of Logic Apps, Service Bus, or Event Grid, right? You'll start to see more of these use cases kind of go to production with customers that are infusing AI everywhere. Of course, the most common one is, I think, earlier in the APIM one, they showed kind of how you can use APIM to improve sort of availability and flexibility, etc., with the reasoning engine. In addition, it's early days, but we're seeing some sort of embodied intelligence come into play. Maybe you want to do some, you want to infuse sort of intelligence in your IoT sort of device or devices that have sensors and actuators, right? Of course, we got to be careful here, but we have solutions with Event Grid as well as a combination of Logic Apps, etc., to achieve that. This is just getting started, and I'm seeing a lot of customers sort of start at least show some interest in doing reliable agent loops. So I don't know if folks have heard about AutoGen project from Microsoft. There's also Semantic Kernels Planner, as well as the new Assistance API that got announced. So again, there you're going to want to run them reliably, and to do so reliably, you want to use a combination of all the Azure Integration Services that we just talked about, especially Logic Apps, etc., so that you can run those workflows that are reliably defined. We're just getting started with all this, I feel like. The goal, again, is to reduce cognitive load required to interact with information systems and create new experiences, right? That's sort of like the idea. And this is a mind share that Andrej is from OpenAI is kind of driving that. LLMs are really going to become like the new operating systems, where everything is sort of going to be round tripped with it because, again, of its generality and reasoning capability. And in fact, there's a project by sort of NVIDIA that is showing that even in edge devices, how you can use LLM to by round tripping with LLM, you can get almost human-like performance, if you will, with edge devices. So the idea here is that there's going to be a lot of AI infusion, and AIs can introduce the quality attributes needed. This is just a sort of sample app that we have, but you're going to, of course, baby step your way into adding AI, sort of infusing AI into your apps. You probably have existing cloud native services, that are, let's say, hosted in a sort of reliable and enterprise grade fashion with APIM and all the best practices that we talked about, and kind of using our integration services. But now you're probably going to bolt on AI, with a lot of the orchestrators or just API calls, things like that. And as you do that, you're going to realize that again, that those quality attributes become very important, right? Like if you have a plugin, like how do you sort of kind of host them? We just saw an example with Logic Apps and things like that. Now, I don't have too much time, but you can go to this aka.ms/Miyagi to see the sample app in action. And earlier I mentioned that demo that my colleague did, David Barkle, did with APIM. You'll also find that policy example there, as well as the workflow definition for the Logic Apps in this repo. Now, just to kind of close out quickly, every AI app is going to be an AIS app because, as you introduce these productive workflows to reduce cycle time or personalized experiences to improve customer retention, you want to do so, reliably, securely, and all the abilities in place, right? This is a good chart by Gartner, and it's kind of what I'm seeing as well in the industry right now, where initially, there's a lot of internal sort of back office applications that are kind of deployed to production, if you will. Again, those are to make knowledge workers more productive, but we're also starting to see, especially retailers, etc., starting to introduce this to external users and to personalize or hyper-personalized experiences. So yeah, so with that, just keep in mind that integration services are kind of key to developing your AI apps, and feel free to reach out for any questions. Yeah, with that, thank you.
Thank you. It was a really interesting session, and I was actually watching as a spectator instead of a producer here. Hopefully, I didn't miss anything. But we don't have any actual questions on the chat for that last one. I share a lot of your links there, and people that is interested in reaching out or to watch that, just remember that it's going to be is being recorded, and we're going to be sharing that later on. I'll pass it on to you to final remarks, Alex.
Yeah.
And thank you, Govind.
Absolutely.
Yeah, thank you, Govind. Yeah, all right. Thank you, everyone, today. I hope everyone enjoyed all of our sessions, and thank you to everyone who is a part of, Azure Integration Services. Thank you so much for coming on. It's lovely to have all of our friends, and of course, all of, Wagner, Kent, and I's fellow PMs as well. So we hope you guys enjoyed, and of course, keep your eye out on the newsletter for more. And this will be our last live stream for the year. Just one final reminder on that one. So this was kind of our hat off to the end of the year, and we look forward to seeing you guys for our regular live streams in January.
Thank you. See you, everyone, and hope you enjoyed the show.